This is machine learning 101, is that LLMs are not stochastic parrots. Anybody who calls an LLM a stochastic parrot is just revealing their ignorance of machine learning 101. The whole point of machine learning is to generalize. And you can test this. And in fact, good experiments with LLMs test this. The text that you just gave me, was it regurgitated or is it different from anything in your training corpus? What I'm suggesting here is nothing less than a different political system that is better than libertarianism. It's better than Marxism. It's better than anything we have today. It's something that Milton Friedman couldn't have imagined, or Keynes, or Marx, or whoever. Like, the technology for that didn't exist. But we have the technology to create a better functioning, more effective, more democratic society than we had before. You are putting into law something that people don't even know how to do. Are you serious? Is this a joke? The AI Act, actually, the best part of the AI Act is that it outright outlaws a whole series of important applications of AI in the name of that they're too high risk. Like, for example, it outlaws emotion recognition because it's too invasive. I mean, like, you and I can talk to each other productively without emotion recognition. Why would an AI be able to, if you want better, more reliable chatbots, they need to have emotion recognition. And the European Union just outlawed it. This is absurd. AI, qua AI, should not be regulated at all. Trying to regulate AI is like trying to regulate mathematics. We should regulate calculus because bad guys will use calculus to make rockets and attack us. Or we should regulate quantum mechanics because nuclear bombs will be made using quantum mechanics. This is ridiculous. We should regulate Python because the bad guys will write Python scripts to steal our credit card information. No. What needs to be regulated is not AI, quantum mechanics, or Python. It's the specific applications. Tylenol is opaque. We don't know how Tylenol works, but we all use it every day. Transparency is just a proxy for trust. What is really important is that I trust the AI, I trust Tylenol, I trust Prezibot. You know why we're moving too slowly? Because the big danger from AI is not the AI being too intelligent, is that it's being too stupid. People have this fear that computers will get too smart and take over the world, but the real problem is that they're too stupid, and they've already taken over the world. This is not a hypothetical danger. Computers are making bad decisions every day because they have no common sense. It's a model, for crying out loud. It learned from that data. It doesn't know anything, right? The model is amazing. It's learned from 1 trillion words or whatever. But at some level, the computer is very stupid. The way you make the computer safe, transparent, explainable, reliable, all of these things is by speeding up the progress of AI, not slowing it down. I think the single biggest reason to watch this interview is to become aware of 2040, the Silicon Valley satire. I had an enormous amount. Some of the most fun I've had in my life was writing this book because, I just fell off my chair laughing with every one of these things. And hopefully you will have fun reading it as well. But more importantly, it's a very fast book that you can read in a couple of hours, but every page is actually telling you something real about AI. So it's about the most, time-efficient way I can imagine of learning about AI in the tech industry. So, if the only one thing that you come away with, is a curiosity about 2040, I encourage you can actually read the first chapter for free at 24novel.com or on the Amazon, look inside the book page. Just check it out. You might find it fun and also then learn, etc. I think the second thing that I hope people come away with from this interview is I think there are a lot of misguided ideas about AI, abroad in the world today. And unfortunately, they're not just academic or funny anymore. There's real legislation being passed that is extremely harmful. AI has never been more unpopular with the public than now, because they continually being told how dangerous it is and how bad it is, or how incompetent and whatnot. And I really think it's urgent that people have a better conception of AI. And this starts with the experts. The lay people, it's actually not their fault. A lot of these illusions about AI come right from the top. And I understand where they come from. A lot of this AI alarmism and Terminator scenarios and whatnot, there are people that have a lot of respect for it, but they're just wrong. We touched on a number of things that I think are going to be very important. One of them is things like symmetry-based learning. I really think that's going to be a big thing. I think geometric deep learning is very good, but it only gets us partway there. We need to start discovering the symmetries and combining them in flexible, cost, probabilistic ways and whatnot. This is one strand. I think neurosymbolic AI is another very big strand, so I very much believe in that. You will find out, this interview has just a teaser about the work that I'm doing in Tensor Logic, which I think, and again, I'm biased, but I think it's a much, much better unification of symbolic and neural AI than anything that we have previously by far. And honestly, for example, if you're an investor or a VC today, I would say be very careful about pouring billions of dollars into stuff that I personally know is already outdated. And I could be wrong, right? Machine learning is an experimental science, but you should at least be aware that there is this scenario where someone already has a technology on the drawing board in small-scale experiments that makes all these thousands of LLM tweaks irrelevant and worth zero.
The Brave Search API brings affordable developer access to an independent index of over 20 billion web pages. Well, it's built from scratch without big tech biases, powered by real anonymized human page visits to filter out data and refreshed daily with tens of millions of new pages. Perfect for AI model training and retrieval augmented generation. Whether you're working on language models or information retrieval systems, Brave offers representative datasets and up-to-date information affordably. We'll get started with 2,000 free queries monthly at brave.com/API.
I'm an AI researcher. I'm a professor of computer science. I've been doing research on machine learning. That's my specialty since the 80s. When I got into machine learning, no one believed in it. AI was not, even in AI, no one believed in machine learning, but I thought machine learning is going to change the world. And it was in such a primitive state that I felt I could make a big impact in a way that you can't in physics or biology. So, I've made a bunch of research contributions. I was involved. It's been a very exciting time, honestly, from the 80s to now. Things keep growing. And I helped start things like adversarial learning, statistical relational learning. I got into deep learning way before it was cool. There was a point at which there was a list of all the deep learning groups in the world, and there were 20, and mine was one of them. So it's been quite a ride. And then I wrote, the master algorithm, which was my attempt to write a book about machine learning for a general audience, so that everybody could understand it not at a technical level, but enough to make decisions about it and use it. And that book, the timing was very fortuitous. I started to write it before the big AI wave hit, but it came out just as it was hitting. So a lot of people, like from CEOs, like one of the audiences that I had in mind was the CEO of a company needs to understand AI. And for example, Jensen Huang, when they were pivoting to AI, he told everybody at the company, you must read this book. I still run into people from me, and he spent a morning, in my office asking me questions about AI and whatnot. So it did that job. It also enabled me to talk with a lot of people in all walks of life about AI. And that's part of what led to 2040, was the realization that at the end of the day, better than explaining something in 500 pages of nonfiction, if I want to convey to people, for example, what AI really is as opposed to Terminator, I think there is no better way than write a good story that will captivate people and will just illustrate AI as I think it is. So that was really one of the main goals in writing 2040. I've always been intrigued by film directors saying that the editing room is where the movie is born, which sounds very counterintuitive, right? Like the shooting. But then I actually realized that this is true. Like when you're shooting, this is more true of a movie than, say, an interview, but like it's just a bunch of disconnected stuff. And it's when you start editing that the whole becomes bigger than the sum of the parts.
Absolutely.
So editing is truly crucial.
Yeah.
Yeah. So I understand why they said that. Now, in the beginning, I didn't.
Yeah. There are intentions at every single stage of the process. So the script writer had an intention, the director has an intention, the editor has an intention.
But in the end, like the movie could come out completely different depending on how it's edited.
Exactly.
And the thing is that like the movie this is like natural language and abduction. What happens in the movie is it's how you fill in between the scenes.
Yeah.
That's where the real action in your brain is. And that entirely depends on what scenes you put next to it, down to often very fine details.
Yeah.
So how you do that? Like the best directors actually know exactly where to cut and to what. And
sometimes things are very motivated. So you want the user to think, the consumer to think a certain thing, but you want to leave a little bit of variance as well.
there's directors like, say, Spielberg, who they are masters of manipulating you in a very precise direction. And they have to know what you're thinking in order to do that.
Yeah.
There's also the ones who, in the end, to my mind, are better, who what they do is it's funny because it's a dialogue.
Yeah.
The best directors, we in AI tend to treat ambiguity as a bad thing, but it's actually not. If I can say 10 things at once and let others fill in the blanks, that's actually good. It's better communication.
Yeah.
So they leave a space for different people to, interpret the movie in different ways.
Do you think AI should change our mind?
AI does change our mind, number one. But you're asking, is that a bad thing or a good one?
Yeah. Do you think it should be persuasive or sycophantic or?
Oh, great question. Neither.
Okay.
AI, a lot of AI will be sycophantic. In fact, that's what our LHF does, right? It makes AI sycophantic, and that's a big problem. Sycophantic AI will sell well. So we're going to have a lot of sycophantic AI. Most of AI doesn't interface with people, so that's irrelevant. But the interface, the AIs like chatbots that are the interface with you, they're often going to be very sycophantic. On the other hand, right, like part of the success of a bot like Zhaowai's, right, is probably the best early example of a very successful chatbot in China, right? Has, hundreds of millions of people who love it. Literally, teenage boys say they love Zhaowai's, the teenage girl persona. Is what they've learned is that you're actually more engaging if you're not too sycophantic. Like, the boy says, oh, I had such a terrible day today. And sometimes she commiserates. And other times she's like, man up. Yeah. And that is actually engages you more. So the sycophancy in some ways is actually, there'll be a lot of it, but up to a point. Now, on the other side of things, should AIs try to persuade you of things? There'll be a lot of AIs trying to do that, from trying to persuade you to buy some product to try to persuade you of some, political party's agenda or ideology or whatever. There'll be both of these, but what serves us best is neither. Your AI shouldn't be trying to persuade you or just massage you. It should be trying to amplify you. It shouldn't be trying to persuade you of something. What it should be trying to do, and I guess this is very idealistic, is like help you get to the best possible understanding of whatever issue or material you're trying to understand. That's the job of the AI. And then also to help you do whatever you want with it, which will be different for different people, right? It will help criminals commit crime, unfortunately, just like cars and text editors do, but that's life, right? We'll have the AI police to combat that. So I think the best AI is not, I like the idea of a co-pilot. I think that's not a bad image. They took a while to come up with it, but it was good. But but co-pilot is still not quite right, because it's your second in command, right? AI is not your second in command. Your AI is you. Your AI is like, an exoskeleton for the mind. It's like power steering for your mind. So the will, the control, the direction is all yours. The AI should just amplify it.
Yeah, this is a bit of a theme in your work. So you're arguing for this wisdom of crowds, individualistic approach, and you are arguing against this kind of top-down governance or autocracy type thing. But isn't that basically what Ayn Rand argued for?
Is what she argued for.
So she argued for we should strengthen the individual, and then moral collective structure emerges.
To clarify, I'm actually not arguing for strengthening the individual.
Okay.
And in fact, I hate to disappoint my libertarian friends, but I'm not a huge fan of Ayn Rand. I think the bigger vocation of AI, that's part of why it's not just a co-pilot, is not to amplify our individual intelligence, although there'll be plenty of that and it's good. It's to amplify our collective intelligence. This is the real killer app of AI, is to make us more intelligent as a society. And this is what 2040 is about at the end of the day, is AI that is really a way to, it's the crowdsourcing idea.
But I think that's what Ayn Rand meant. So she said that when individuals follow their own gradient, then you get the emergence of collective intelligence and morality.
And I completely agree with that part. Right now, the question is, and this is where AI kind of changes the game. To go back to Ayn Rand for just a second, That is true to a first approximation, but then it has many places where it falls flat. To take a classic example, markets are one of the greatest inventions of humanity ever is just markets. Markets are amazing and people don't give them enough credit. So, more power to that. However, markets have a lot of failure modes, most of which come from the fact that it's trying to harness my selfishness to help the greater good. And that is necessarily going to have a lot of failure modes. A lot of the ways that we have today of fixing those failure modes, like government regulation and whatnot, they're very problematic in their own right. Often they're better than nothing, so we can have them, but often they're worse than nothing, so we're better off without them. But between like markets and governments and more or less regulation and guardrails and all of that and externalities, what AI potentially lets us do, which is really exciting to me, is that think of this as mechanism design. Mm-hmm. Right? What should the mechanism be? A market is a mechanism. A constitution is a mechanism. But it's a very old mechanism. The way politics runs now and the way our collective decision-making runs now is something from the 18th century, right? Back then, you elected some representatives and then they made some decisions for you and passed some laws and whatnot. Like what AI can do, and this is in fact what the AI in 2040 does, is like in real time, it's taking input from everybody on the issue at hand, not just trying to generalize poorly from some data that it mined like ChatGPT does. Right? It's a collective intelligence of 100 million people acting fast and very intelligently, as opposed to very slowly and imperfectly. And part of what it's doing all the time is resolving conflicts. There's no kumbaya here. Right? The company that made it is sarcastically called kumbaya, but because that's not what happens. It's resolving conflicts at all levels and coming up with decisions that are the best overall at any given moment. But the bottom line is that at the end of the day, it's the intelligence with AI of a society will be much greater than the sum of the parts, exponentially, I can even say, in a mathematical sense, rather than today where a society is more intelligent than an individual, but the intelligence of the society is actually less than the sum of the intelligences of the individuals, and that's the tragedy.
I agree with all of that, but don't we need to have some kind of value function? Right, because I think you've said previously that someone out there in their bedroom has probably already invented, the next generation of AGI technology. And we have all of these biases like social proof. So we don't pay any attention to them. It's dominated by the current status quo.
No, we need to have a value function. In fact, we need to be explicit about it. And again, AI is, right? And every AI system is governed by an objective function, or value function, or reward function, or whatever you want to call it, or metric. There's many names for this. And indeed, that is the locus of control of AI. If we're going to have fights about AI, it should be about that. But what I think even more importantly is that we shouldn't try to pretend that there's a common value function for everybody. That's just going to make society stupid and not serve us very well. Maybe it serves some people very well, but not most of us. The AI needs to know what the value function of each one of us. My AI, its legal job is to maximize my value function. If it's illegal, it should be shut down, but to maximize my value function. The job of, for example, suppose there was an AI, as in 2040, that is the president. What is its job? It's to maximize the collective value function of everybody. And what is that? In a basic democracy, utilitarian way, it's the sum of the value functions of everybody. So that's what it should be doing, is maximizing that. And if my value changes, its value function changes. So this is, I think, how things would work. Let me give you another example. You know the movie Inside Out?
No.
Right? Inside Out 2 is actually the highest grossing cartoon movie of all time at this point. Came out this summer. The original movie Inside Out is about what happens in a teenage girl's, then it's a little girl, now it's a teenage girl, it's a girl's head. And what it does is it personifies the different emotions. There is an anger character in her brain, and a joy, happiness character, etc., etc. And what this does that it's beautiful is that this is what is actually going on in your brain. You don't have a single objective function. That is too stupid. You have a whole bunch of different objective functions: fear, hunger, pleasure, greed, the whole gamut. Each one of those is there for a reason and is in control of a different part of the machinery, and your intelligence emerges from the interaction of all of these. And I would say that in a society, what should happen is the same thing, is that the intelligence emerges from the interaction of the value functions of all the components of society, people, companies, groups, etc., etc.
Yeah, I mean, you're absolutely right. Reification, objectification, it basically excludes all of the nuance from our mental state, our functioning, and so on. What about something like Twitter and Facebook? So they are a form of AI collective intelligence. And interestingly, it's built on top of our actual social dynamics. So, we're having a conversation in the real world. We might post about it in Twitter. Presumably, you think that is very, excluding of the nuance in the way you were just talking about. It's not agential.
Social media are a great example, because what most people, the conventional wisdom about social media today is that it's bad. It ruins society. It needs to be stopped. It needs to be tamped down on, controlled, guardrailed, restricted, blah, 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 blah. And, first of all, social media, despite its very real pathologies, overwhelmingly, it's a huge force for good. When Mark Zuckerberg, says we're connecting people more, and this is true. Some of it is self-serving, but some of it is very true. Facebook gets used, to connect people, their families, their groups from high school, and people with a particular interest trying to accomplish something. It's incredibly useful. Number one, we got to keep that in mind. But here's the key point as it relates to AI. The problem, to me, the solution to the problems with social media is not to tamp down on it. It's to improve it. And in particular, to improve the AI algorithms that are actually running the system. Twitter and Facebook are basically an AI system choosing what everybody sees. And this is incredibly powerful. And right now it's very dumb, precisely because, in contrast to Inside Out, it just has one objective function, which is maximize engagement, which is what maximizes the money that the company makes, but is also a perfectly reasonable thing. It's trying to show me stuff that I'm interested in, right? There's actually nothing wrong with that. But a better system would be precisely one that supports think of a better version of Twitter powered by AI. You actually have a productive discussion where everybody who has something useful to contribute contributes it. The noise gets filtered out because the signal prevails, and collectively we can decide things on Twitter. All the insults and all of that stuff goes away, and the whole thing actually becomes an engine to this greater collective intelligence. So what I was just talking about, social media are potentially the ideal vector by which it could come about.
I agree. I mean, I spoke with Kenneth Stanley, and he's built a network called Maven. A serendipity network which does quality diversity, so moving away from the objective convergence of likes and so on. But let's be honest, we use social media now, and it's engagement farming, it's addictive. There was that film, The Social Dilemma, and it said it doesn't overcome our strengths, it undermines our weaknesses, right? So there are people that have tried to fix this problem, and honestly, not going very well.
No, I understand, and that is the key problem. But here's the thing. Let me use a somewhat incorrect analogy, but it's a useful one. It's the mammalian brain and the reptilian brain. When the reptilian brain is in control, it does reptilian things. Like you want to be liked. You do those things for the likes, and you spend hours on it, and you get into these whatever ego battles and whatnot. These are very strong tendencies in us that social media currently amplifies. And it seems hopeless to try to redirect from that into rational discussion. That never happens, I feel. It's like the internet is going to make the world more rational and better education, and then it's the cesspool. But here's the thing. The way you overcome that is the same way that evolution did, which is with your mammalian brain. You need people to, for example, I would like to be in control of Twitter and say, what I want out of Twitter is to learn more. Show me stuff that teaches me, new things. So that level of my brain, the level of your brain that makes, New Year's resolutions, this is the one that should have control of your social media interface. And not control over the company that's running it, control over your bad impulses.
Yes.
Right? And this is, again, like everything in technology, this is just a more powerful version of a dilemma that we've had all along. And right now what social media is doing is it's empowering the reptilian brain with, of course, lots of bad consequences. We got to realize that that's not going to change. We need to change the mechanism to empower our mammalian brain, which, of course, we have things in our society that do that, like the education system, the justice system, right? The justice system says, well, instead of resolving problems through violence, let's have this procedure, right? And it works, not perfectly, but way better than what it did before. So I think we can do that with social media. And lots of people will do lots of experiments. Most of them will fail, but it doesn't matter. Once one of them succeeds, it'll be revolutionary.
Could you reflect on your own experiences on social media? I mean, because even though it seems like this, thing that encourages autonomy and agency and so on, but actually you lose control of your own narrative, and that's because of this mimetic information sharing. So the narrative of Pedro Domingos is controlled by other people, and that creates a form of misery. Do you know what I mean?
Let me distinguish between, say, Twitter and Instagram. Okay. Right? And somebody said that Twitter is all about I'm smarter than you, and Instagram is all about I'm more fabulous than you. Right? and Instagram creates misery because all those teenage girls on Instagram get the illusion that all the others are more glamorous and have a better life and blah, 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 blah. Twitter is a little different. Twitter is about people with an opinion, with something to say. It's a platform. The problem with Twitter is that whatever you're saying it in public. So the behaviors that we like, it's almost impossible to have a normal discussion between two people on Twitter because you're posing for a larger crowd and trying to, and then all of that dynamics comes in. Reddit, for example, is very different. Reddit in some ways is actually a much better platform. Like you have more sensible, useful, informative discussions there, but it has fewer users, right? So you gotta understand the dynamics to then bring it to do what you want, right? And I think, social, for example, when I use Twitter, right? I don't try to use Twitter to have enlightened discussions. That's it's not impossible, but it's unlikely. Twitter is good, but it does. Twitter as it is actually has a function, and a useful one, I believe, which is to put out small snippets of information. It's very efficient in that regard. If Twitter's algorithm was better, every tweet would be something useful, and my role as someone who posts is not to post long essays. That's not the place. It's to post one sentence that, in my opinion at least, really nails something that people need to know, or is a hypothesis that people should contemplate, and ideally it starts a discussion. Right, so in that way, I actually think Twitter is fine. It could work better in terms of doing this, but even just that narrow function is already very useful.
Yeah, but your Twitter is actually very sophisticated. You're creating small envelopes for quite big payloads.
Well, that is a great way to describe it, which I hadn't heard before. Exactly. It's fine if people tweet at random, whatever what they had for breakfast that day. But I have a lot of respect for my followers, and what I want to do is make the best possible use of their time. So what I try to do, this is quite conscious with my tweets, is I tweet a sentence that it's a tip of an iceberg. There's a lot of thought behind that, and I'm actually glad when people push back or ask a question, because depending on the interest, right, we're all pressed for time, then I can elaborate. But I'm trying to say in a way, in one sentence, what in the previous stage I would have said a whole essay about.
Maybe we should just quickly go back to the master algorithm. You were basically arguing that there could exist a universal algorithm. If only we could merge together all of these disparate tribes, we could have a universal algorithm of learning. What do you mean by that?
What the title, the master algorithm, is trying to illustrate is really what the essence of machine learning is, which is something very new and very intuitive to people. My argument is that we all in machine learning work on the master algorithm, even if we don't admit it. And what do I mean by that? Is a master algorithm is like a master key. That's where the analogy comes from. A master key is one key that opens all locks. And a master algorithm is an algorithm that can do everything. And that sounds unbelievable, right? But this is what we have today. The secret sauce is data. The same backprop algorithm that David Romerhart invented in 1980-something, it can fly a plane, drive a car, play chess, fuel a chatbot, do medical diagnosis, the same algorithm. This is just a mind-boggling thing. And if you go back to Turing, the insight that he had that was very strange for the time was you can have a machine that does everything. It's not a sewing machine, it's not a typewriter, it's a machine that does everything. And at the time, this was a very odd notion. Today, we take it for granted, but Turing only had half the thought. Because how does the machine get to do that? It had to be programmed by you and me. So now I have to write the algorithm, and really, the machine with the algorithm is just a different machine. The beauty of machine learning is that it's the missing half. Is the machine now, but it's by itself. Just by observing the world and interacting with it, it actually gets to do these things. But now, of course, if you buy this premise, the question is like, so what is that algorithm, right? What is the Turing machine of induction, if you will? And there are candidates, there's backprop, there's people like Jan LeCun who think, backprop is going to get us there. I'm skeptical of that. The people in symbolic AI have their own algorithms that they think are the answer. And my contention in the master algorithm is like, which of course is a good excuse for a tour of these different tribes, as I call them, is each one of them has their candidate master algorithm, backprop in the case of the connectionists and so on. But that master algorithm solves a particular problem very well. In the case of backprop, it's credit assignment. But the problem is that intelligence consists of all of these problems, and you will not solve it until you have an algorithm that solves all of them. And so we should unify them in the same way that in physics, they've unified the four. People don't say gravity does everything, never mind electromagnetism. That's laughable, right? And to me, the same notion in AI is laughable. So we need not just some superficial combination, but a really deep unification of those paradigms. And moreover, we have made enormous progress towards it. At this point, I have no doubt that we can achieve it. The question is, will that be enough? Or will we need something else beyond that? And that remains to be seen. I would say probably we do need something beyond, but one thing at a time.
Yeah, because you mentioned symbolic, and we'll come back to this later. But what's interesting about that is it's not a learning algorithm. So humans design structure, and it might be a set of rules or some kind of like calculus or grammar or something like that.
No, I'm glad you asked that question, because there's people, and I understand why, they associate symbolic AI with knowledge engineering expert systems and whatnot, because that's what was famous. But there is such a thing as symbolic machine learning. And that's actually, the group that I did my PhD in, that's what it did. And symbolic machine learning goes back to the 70s, actually even earlier. And in particular, the whole field of inductive logic programming is symbolic learning. And in particular, their master algorithm, I would contend, is what they call inverse deduction. Inverse deduction is truly doing induction by inverting deduction, which actually the idea goes back to the 19th century, and Jevons, this economist who, among other things, actually invented inverse deduction. Of course, in the modern world of AI, it has been operationalized. So there are the two main conferences in machine learning are NeurIPS and ICML. NeurIPS was originally the connectionist conference. ICML was the symbolic machine learning conference. So there's a whole field of symbolic machine learning.
Sure. So I know we're both fans of geometric deep learning and neurosymbolic architectures and stuff like that, but something like discrete program search or inductive logic programming, you still need to come up with these, basically these kind of priors, knowledge about how the world works, and you imbue that into the algorithm.
Well, yes, but that is true of everything. It's the no free lunch theorem. Without prior knowledge, you can do exactly zero learning. And the only question is, what prior knowledge do you put in there and how much does it accomplish? And precisely what the tribes differ in is the prior knowledge that they put in. The Bayesians put in priors and model classes, the connectionists put in architectures, the symbolists put in knowledge bases. And often like biases about like what the rules that are learned should look like and whatnot. One of the things that distinguishes the symbolists, which is actually a great strength, is that they're actually quite explicit about this. And as a result, they can put in knowledge of a much more elaborate and developed and advanced variety than just like, here's an architecture or here's an uninformed prior. So this is actually a big plus of the symbolists, is that you can learn on top of an existing large knowledge base.
Yeah, and symbolists, they try to model their abstract knowledge on the human psyche. So, I guess we could both say we are empiricists in the sense that if we've got billions of years in evolution, then we can start from a blank slate because all of this structure can emerge. But building useful AI systems, we're actually trying to bootstrap the process. We're trying to make a shortcut by coming up with these priors and then build algorithms which learn much more efficiently.
To be fair, within the symbolist paradigm, there are the neats and the scruffies.
Yes.
Famously, that used to be the big schism in AI back when connectionism was irrelevant. The scruffies are very much inspired by psychology, like Newell and Simon Minsky, some of the founding fathers. And I'm all for that. Why not reverse engineer the competition? Right? This seems crazy. Yes, AI can be very different from human intelligence, but we should at least learn what human intelligence is doing. But there's also this other neat school, of which the leader was John McCarthy, of course, but became very powerful, even dominant, where they reject human psychology. They say human psychology is a mess. All we do is screw up. We're irrational, etc., etc. Again, the Bayesians are like that too. We need to derive AI from first principles, from logic and from math. So there's a whole school of AI that, and I think it also has things to contribute, but honestly, my reaction to that has always been from the day I first read a book on AI and from talking with McCarthy when I was on sabbatical in Stanford, and he still laughed at and I didn't put this to him quite this way. It's like, you're so deluded. You are completely in la-la land. You think you're going to solve AI by writing a bunch of formulas in first-order logic? What are you smoking? I agree with Jeff Hinton there, like that, they're smoking something.
So you're a scruffy, but the thing is, though, you would presumably agree that there are some things you can do with that kind of formal approach that you can't do.
I'm glad you asked that question. I'm not a scruffy. What I think, and I thought from the beginning and still do, and that was what informed my research throughout, is the following. I want AI to have formal, sound mathematical foundations. Why wouldn't you? Part of my beef with a lot of AI, and today this is worse than ever, is that people are just hacking left and right. There's a place for hacking, but you shouldn't hack until you have to. At some point you have to, but let's start, let's not do the Apollo project of AI today, like Demis likes to say. We don't even have Newton's laws yet. But my contention, so I want a formal foundation for AI, which I agree is not going to solve the whole problem, but is going to be essential. I think without that, we'll always be stuck in plateaus and local optima. But first-order logic is not that foundation. And all its variations that they've published thousands of papers about. First-order logic is part of it. And again, my candidate for the master algorithm at the time that I wrote it was Markov logic, which is precisely taking a step towards what we want by combining the logic with the statistics and the probability, which is also essential. The real world is full of uncertainty, ambiguity, contradictions, etc. Logic deals with none of that. Non-monotonic logic, which was, John McCarthy's, maybe most significant idea. It's hopeless. We needn't go into it. But so we need a formal foundation. The master algorithm will follow from that. The formal foundation, unfortunately, is not what this Scarfe has worked on for 50 years. That was just, a dead end.
So a lot of people out there are saying neurosymbolic architectures should be scruffy first, then neat. So we do the neat for the verification. Are you saying it should be kind of neat, then scruffy?
Yes, I think I like the way you put it. I think we always end up scruffy, look at any real computer system. But it's better to start neat. But I'll give you maybe an interesting analogy here. Think of a very relevant one. Think of programming languages, right? When John Backus has decided to create Fortran, most people thought, this is ridiculous. You're never going to succeed. A high-level programming language, you're smoking something. Just like they said of AI people and McCarthy and whatnot. And then they pulled it off. And it was a fantastic advance, right? Which we all rely on today. Imagine programming everything in assembly code. But here's the thing. The first compiler, the first Fortran compiler, was an ugly pile of hacks. That thing was so ugly. So in that sense, the Scarfe came first. But today, and this is the brilliant achievement, is I can build a compiler to an undergraduate student as a course project. What happened in between was that the NEETs came in and they cleaned up all the mess and simplified it and systematized it to the point where it becomes easy for everybody. And my contention is that, so the NEETs and the Scarfes alternate in all technology. Today we are at the point where we're going all out Scarfe. 99% of what we're doing is just wasting electricity, among other things. We need the NEETs to come in and clean this up and figure out what is about transformers that matters, for example, and what is that doesn't. And then we'll be mature. I'll tell you one last thing that I forget who said this, but it's great. It said, a young field has small textbooks, right? There isn't that much to know. The textbook from which I first learned AI, it was, Elaine Rich's was the first AI textbook. It was a small, trade size 400-page book. Because, there wasn't that much. Now Russell and Orvig keeps growing. It's over 1,000 pages. Yeah. So, and then a more mature field, this saying goes, has large textbooks. But a really mature field, the textbooks are small again. We need to, right now we're in exponential growth. We need to get back to the small, and this is where the neat part and the master algorithm part come in, and that's what I want to contribute to.
But how big is the neat opportunity? I mean, a great example is Python's a formal language. Natural language is very, very scruffy. You can't write a compiler for natural language.
No, but I mean, don't pursue that analogy too far. I mean, I can tell you where I think there's an opportunity for neat, because that's what I'm working on, right? I'm voting with my feet, right? I think this pretty strongly, and the next few years will tell us. We really can, again, setting that analogy aside, look at things like LLMs and transformers and whatnot. What we have right now truly is a big pile of hacks. Nobody denies that. Like, I forget who said this, but like trying to get a deep network to work is like trying to balance a pencil on the tip of your finger. This is like, it's true, right?
Yes.
It's that fine of a problem, right? Yeah. So I think we 10 years from now, or even less, we are going to have principles of designing AI systems by which we have something that is much better than today's LLMs. In particular, it's not that AI is scruffy and natural language is scruffy, and that's good. The scruffiness is actually an asset. We could go into that, but like, natural language is superior to formal knowledge representations. What we need to formalize is the machine that handles the natural language, where machine learning is essential. This is what the psychs of this world and the whole symbolic school of like knowledge engineering didn't really get. And that I think we can, and there's all this learning theory, right? There's a lot of people who work on it. It hasn't really gotten that far because, again, I think we did a different kind of learning theory. But for example, one area that I believe a lot in, and again, was doing it since before it had a name, I call it symmetry-based learning. Others call it, geometric deep learning, which I think is confusing because, I've talked with someone who's like, this isn't just deep learning. You're like, yeah, I know, but for marketing purposes. And it's not geometric, like group theory applies to many things besides geometry. But symmetry-based learning. So I think AI will naturally stand on a bunch of legs as foundations. Logic is one. It's just not all of them. You can't have a stool with one leg. Probability is another. Optimization is another. We are very familiar with all of these. But I think a fourth one is a symmetry group theory, which if you're a mathematician or a physicist, this is like, duh, of course. But in AI, that idea still doesn't fly very high.
Well, you say that, but self-attention transformers are literally a form of geometric deep learning. They have a permutation symmetry built into them.
So they are, again, I would say they're a form of symmetry-based learning because they have permutation invariance built into them.
Yeah.
And now there are a lot of these invariances that we know. An even better example, more basic one, is convnets. What is convnet? The convnet is a multi-layered perceptron with translational symmetry built into it.
Yeah.
And we have an extension that is deep affine networks that builds in any affine symmetry, rotation, blah, blah, blah. And it learns from less data, much less, of course. But here's the thing. All of this is well and good, and what people have been doing in this whole field so far is well and good. But I think the really important thing is to have your system discover new symmetries. Not just use known ones. And I'll give you a very concrete example of this, which applies to natural language. So one of my students did this beautiful paper on symmetry-based semantic parsing. So semantic parsing is extracting the content, the meaning, from the syntactic form of the language. And the problem, this is the central problem, is that that LLMs also have to deal with, the syntactic form is exceedingly variable. And in some sense, the semantics is really the invariant in what you were saying. It doesn't matter whether you use passive or active voice or you said this or the other. What matters is the content. In fact, when you do experiments with people, they don't even remember what the form was. They remember the content. And so, every paraphrase, every synonym, all of these things are symmetries, and the language has a symmetry group. The English language literally has a symmetry group that is different from the symmetry group of French or Chinese. And if you completely discover that symmetry group, this is coextensive with completely discovering how that language works. And you can discover the symmetry group from text, from corpora of paraphrases, and even from raw text. By noticing what are things that are different, but you can infer they're actually saying the same thing. And we actually have some preliminary work towards it. So it's very well-founded work, founded in symmetry group theory, on solving the problem that LLMs today are solving very badly.
Interesting. So you're arguing that there's a master symmetry group for language, and this goes against. I've had Nick Chater and Morten Christensen on. They wrote The Language Game. They were arguing language is gnarly. it's incredibly gnarly. And I'm amenable to the idea of having, in GDL architectures, we handcraft the symmetries, we could have a plasticity, we could learn the symmetries. But you're saying, no, in language, there is some symmetry group.
No, great question. Here's the thing. Language is gnarly, and I'm not denying that. But this is where the symmetry groups for language and AI are going to be very different from the ones that physicists use. The symmetry group of the English language is a vast and growing thing. There's this thing called the generator of the group, right? The whole group is generated by those, like the traditional groups, right, have very, very few generators, very simple ones. The generator of the English language is a vast, complex thing. It's forever evolving. It's not fixed. But you still have it, which is what allows you to convert blah, blah, blah into meaning in your head. Number one. Number two, the symmetry groups cannot, this is, I think, a big mistake that people consistently have made. There's some papers going beyond that, but for the most part, the symmetry group cannot be applied deterministically. It's just like logic and Markov logic, right? Like an example that people always mention to me when I talk about this is like, oh yes, rotational symmetry, but a 6 is not a 9, right? Precisely because the symmetry doesn't extend all the way to 180 degrees. Like, it's more like you have these operators, and every time you apply one, you pay a cost. And now your parse is the lowest cost parse, which of course is a notion that we're incredible. It's the MAP parse if you want to think in terms of probabilities. But so the symmetry group theory needs to apply with the same intervention of probability and optimization that we did in Markov logic with logic. And, like this, if you think of someone from my background thinking about symmetry group theory, it's like very natural. So I'm not arguing that language, there's some beautiful, simple symmetry group that analyze language. On the contrary.
The thought occurs, though, that this is actually surprisingly similar to Chomsky. And we had Chomsky on the show, spoke about this hierarchy of automata. And you recently tweeted that LLMs learn and Chomsky doesn't. So I don't think you have a great view of Chomsky.
Yes, as that tweet reveals. And what that tweet is alluding to, again, as an example of what we were talking about earlier, there is one short tweet that has a large amount of history behind it. Right? You could write not an essay, but a whole book underlying that tweet, which is the following. And, talk to the linguists and to the computational linguists, like people like, Chris Manning and then, et cetera, right?
Yeah.
And what happens is that, like, Chomsky produces one theory after another, all of which fall down when people try to empirically validate it. Nothing that Chomsky has ever done has been empirically validated. At this point, no one even tries anymore because they know it's not serious. But Chomsky, instead of being a good scientist, if you will, he just goes on to the next variation of what he wants to do. And the tweet very precisely is referring to things like the following. Someone was mentioning something that, and I forget the exact case, but it was apropos of this paper, right? But there's an even better example than the paper, which is Chomsky's big contention, and what he's famous for, is the poverty of the stimulus, is that language cannot be learned. You cannot learn a context-free grammar from data. He said this in the 60s. Because blah, 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 blah. We have theorems, we've had theorems since the 80s, even the 70s, proving that you can do that.
The syntax.
Yes, but Chomsky doesn't seem to have woken up to that yet, 50 years later. It's ridiculous. If I give you examples of sentences in a language that was generated by a context-free grammar, can you induce the context-free grammar? And the answer is yes. You can pack learn it.
But he would argue that you could also use it to learn impossible languages. Therefore, it's not, it's not carving up the world in an interesting way.
No. But, so that's a different question, right? So the things like, let's deal with the first one first. Chomsky says that you can't learn English from data, and you can. So taking things on Chomsky's terms, English is not a context-free language, but let's just, entertain him for a bit. Let's suppose that English is generated by a context-free language, and he has whole books about this. So the context-free language can be learned from just a corpus of sentences with no other supervision. There are theorems that say this. Wake up, Noam.
I know, but I mean, you got to love him. I mean, I remember when we had him on the show, he's like, I got a theory. It explains all the rules of the physical universe. Anything goes.
Which is completely unpredictable as well.
Yeah, I mean, so to what extent do you think a language model is actually a useful theory or model of language if it can do anything?
Again, this gets back to the master algorithm. What I want to have, unlike a classical linguist, is I don't want to have, I'm never going to have a complete description of English. What I want is the algorithm by which whatever language you speak, I can learn. So the fact that my algorithm can learn any language is a feature. It's not a bug. It makes it more universal. The specificity comes from the data. This is the lesson of machine learning that Chomsky never learned. I mean, I'll give you, one other example, which in some ways is even funnier. And again, to his credit, like back in the 60s, his ideas were very natural and were in advance. The problem is that he doesn't learn. But he made a big name of himself penning things like Markov models of language. Right? This notion that an Engram model, which is today's even funnier because like in many ways an LLM is still a glorified Engram model.
Yep.
But he said these things in the 60s. In the 70s, DARPA did this big competition for speech, right? Using a symbolic approach with very complicated things like, very Chomsky, you could say, but also going beyond that into semantics. And so this was one system. Another one used an HMM, which is the dumbest damn thing you can imagine. And the HMM won. This is a big lesson. Again, it goes back to the bitter lesson and, and all of that. It's like, we understand that it's because of bias and variance and things like that, right? Like precisely because it's very constrained, if you give it enough state and enough data, it actually learns the stuff very reliably that your pile of hex doesn't. Data is powerful. Data is smarter than you once you give it the right algorithm to learn.
But would you agree, though, that he was a giant of the theory of computation?
No, I would agree. That is a very interesting question. My Engram model failed there. The last word computation is not what I was expecting. I was expecting linguistics. He was a giant of linguistics. And to give him his due, right, he became famous during the rise of cognitive science against behaviorism.
Yes,
right?
Yeah, B.F. Skinner,
and more power to that, right? He was on the side of the angels then, behaviorism. It's interesting because, again, reinforcement learning is the rebirth of behaviorism, but setting that aside, it was important that revolution happened, and he had a large role to play in it. Unfortunately, he captured the whole field of linguistics too much. And that whole community has become honestly irrelevant and outdated. They're not alone. This often happens in science because they can't evolve beyond Chomsky. Whereas in NLP, computational linguistics, we have the data and the computers to force us to evolve. So he was a giant, but his, to give him his due, it's important to have people of the ambition and the intellectual caliber of Chomsky.
But in a way, though, he has some similarities to you. I mean, the behaviorism thing, the poverty of stimulus, that's basically rationalism, right? So, he thinks that there's some universal structure to how the universe works, and he's a strong computationalist. He's done all this work about automata theory and so on. It's really not that dissimilar to what you're talking about.
Well, again, let me put it this another way. Let's talk about physics for 30 seconds.
Yeah.
Physicists believe there's a set of laws by which the universe works. And it's simple and it explains all the complexity. And pre-Newton, you could have said what a joke. It's like, what a dreamer, right? But hey, right? They've made a lot of progress there. But, so you're saying you're like them. But wait, which physics? Newtonian physics, Aristotelic physics, relativistic physics, quantum mechanics, string theory, loop quantum gravity, right? Just because I believe there's a formal foundation to the universe doesn't mean I agree with Chomsky's. I do believe there's a formal foundation for many reasons that we can touch on. It's just that Chomsky's wrong about what it is. That's all.
What's the formal foundation of the universe?
Going straight
just before we
that.
go to your book, yeah.
I'm not a physicist, let me put it that way. But I think I am a computationalist in the sense that I think what physicists are getting wrong today is, and again, with due respect for all their achievements, is that they solved physics with the math that they had. If you look at Schrödinger and Heisenberg and all of them, they were trying to explain what they had with the mathematical equipment that they had. Just like Einstein did with general relativity and whatnot. Unfortunately, that equipment was the wrong equipment. It wasn't their fault, right? And then we went deeper and deeper into this rabbit hole that begins with quantum mechanics and ends in the last 50 years of stagnation. We have a different set of tools today. We have computers. We're in a different world. The universe is computational in the sense that it is best understood as computational. We don't need, so for example, perturbation theory, right? All those Feynman diagrams and all those imaginary particles, they're just confusing themselves with it. We don't need that. We can run the model on a computer. So in that regard, for example, I sympathize with Stephen Wolfram, someone with whom I talk with periodically. He despises mainstream physicists and they repay him in kind.
They certainly do.
And again, he's a bit of a Chomsky-like character in some ways, that like he just believes in his, it was like, where's the evidence?
Yeah.
Right. But I'll give you one example that I think maybe encapsulates this. So, I believe that the universe is discrete, empirically discrete. So does he. Yep. So we both believe that the universe is discrete. Most physicists and most people believe that the universe is continuous. So, I asked them at one point while conversing about these things, why do you believe that the universe is discrete, right? And his answer was, because I have this theory that is so beautiful that says it's discrete. This, summarizing a longer paragraph is what he said. And I'm like, my reaction to him was not quite what I'm going to, say now. It's like, what the hell? The universe is discrete because it is empirically discrete. The experiment said it's discrete. It doesn't matter how beautiful your theory is. I'm not interested in a discrete theory of the world because it's pretty. It's that like when you do quantum experiments, the reality is discrete. And then we put wave functions on top of it and whatnot. There are perfectly reasonable approximations, but right. So I think the foundation. So I think one of the exciting things about today, and if I could fork one of myself to do that, I would, is that as much as the physicists are stuck, I think we're getting closer and closer to the breakthrough, where we have a better understanding of the physical world that, among other things, unifies general relativity and quantum mechanics by reducing both to something deeper. That something deeper is discrete. It's a discrete set of variables, and in a way, this to me is the kicker. The mathematics of that is going to be the mathematics of condensed matter physics.
The thing is, though, I mean, Stephen's a good friend of the show.
Right.
And when we go to the high resolution and we talk about these emergentist ideas, same thing with Carl Friston with the free energy principle. Great, we're in a material universe and we can do Stephen's cellular automaton, or we can do Friston's particle system and so on. And it will give rise to all this complexity. And the problem is we don't have billions of years and all the compute power in the world. What we need to do is build AI systems today with utility, which is why we're looking for abstractions. And Cholet has this idea called the kaleidoscope theory. So he basically says, there's some generating function of the universe, and there are all of these abstract priors which compose together and add together, and we see it as a kaleidoscope. So we see it as this structured pattern of all of these different things mixing together. And an AGI system should decompose the kaleidoscope back into the original priors which produced it.
I think there's two parts to this. I think a very good metaphor for the universe is the Mandelbrot set. The Mandelbrot set is generated by the simplest equation you can imagine. It's really ridiculously simple, but then you iterate it. A very simple equation, if you iterate it, and leads to this explosion of richness and complexity. And what we've been doing, what our brain does, what science has been doing, is like we're zeroing in on some of these curlicues, and we perceive a pattern there, and then another one somewhere else, and then we try to reconcile them, or don't even do that. But what we have to do is drive this to, and again, this is really the agenda of physics, if you will, is drive this to the point, right, where we really see the bottom equation that generates everything. So I think at the end of the day, there aren't a lot of things colliding. There is one thing that generates all of these things. Now, there's a very important thing here which has to do with AI, but also with evolution, is, as you said, we don't have infinite time. So what actually has happened, again, this is actually one of those great, interesting things about the universe, is that on the one hand, there's the second law, but in reality, what's actually happening is completely different, is that complexity keeps increasing and things keep speeding up. This is what evolution did. Reinforcement learning is sped up evolution. What our brains do is try more things more quickly, because instead of relying on mutations and crossovers, we can simulate them in our head. Computers and AI are just the next iteration of that. What we're doing is like we have this process which remains to be elicited, by which this very simple mechanism gets progressively compiled into something more efficient. Getting back to Stephen, right? Another thing I've talked to him about is like this notion of computational reducibility,
exactly,
with which I greatly sympathize, but which he has never really formalized. I actually asked him, so like, what is the formal definition of reducibility? And there isn't really one, but I think there should be one. But here's the thing, right? The universe is not entirely computationally reducible. There are parts that you can reduce, and in fact, this is what we do from the cell to the brain to the computer, is we grab the parts that we can reduce, and then we continue with the random search on the others. But what this does is it speeds things up. So I don't believe in the singularity, but at some level, this is very much the driving towards the singularity, like the compilations of the reducible parts in any form, molecular, neuronal, computational, they keep speeding us up. And it's interesting to ponder where this will all lead.
Yeah, I mean, for the audience, I mean, I think that the simple definition is there are no shortcuts. You have to do the effective computation, you have to do the simulation. But the thing is, though, Wolfram said when he was last on the show that there are pockets of reducibility in the universe. But my bigger point, though, replace kaleidoscope with Mandelbrot set. That's an even better example. So, there's lots and lots of abstract patterns. There's commonality, and we can see it, but it's quite difficult for us to describe it with rules. Our brain does this really well. So we see all of these abstractions all over the place. We have a model of physics in our brain that we wouldn't even be able to introspect or explain. And these abstractions are actionable. We want to build AI that can learn these abstractions in a similar way our brain does, but our brain has benefited from billions of years of evolution, and it's embodied in a very complex way. So it's very difficult to do that in a computer.
So I agree with that, and I would take it even further. I think the grand test of these abstractions is AI. And for example, here's a prediction that I will make. We live in a Newtonian universe, but Newtonian physics doesn't help you solve robotics and vision. We know that. It just sucks. Your brain knows physics, Newtonian physics, better than Newton, better than the physicists do. Your visual system, your motor system have a different abstraction of the physical world, and we're going to discover it because we're going to need to discover it to have housebots. And then when we've discovered, we will also understand physics much better than we ever have, and even get out some of the ends that things like quantum mechanics and whatnot, which at a deeper level are still Newtonian, have gotten us into.
So the year is 2040, and the United States is preparing for a presidential election. Take us from there.
I'm already laughing, right? So there are these two characters in 2040, Ethan and Arvin, who were grad students at Stanford of Professor George Jeffington. And they published a paper in the Conference on Novel Information Processing Systems, NIPS, which is what it really should be called because it's not just neural, on a new thing called intelligence propagation. They think they solved AI, like a lot of people have, but they do a startup, but the startup isn't going anywhere. And then one day, in the lead up to this presidential election, they're, getting drunk in a bar. And there has been this couple of Supreme Court decisions, one which is that all sentient beings are citizens. You can already see that happening, right? And then the next one is that AIs are sentient beings, right? You can also see that happening. Combine those two and then go like, an AI by this standard could run for president. And then Ethan, who's the CEO and the more bold and megalomaniac one, goes like, that's what we should do. We should run an AI for president to demonstrate our technology. And this is how Prezibot is born, a presidential chatbot, which is really just, for these purposes, chatbot in ChatGPT, a chatbot in a robot body. So they run this thing as a stunt, which again is making fun of how AI startups work. You make some stunt that looks better than it is and so on, right? DeepMind started it, OpenAI perfected it, everybody does it. But then the next big surprise is that this libertarian trillionaire, at this point they're trillionaires, gets behind, and again, you can see who this is based on. Everybody, every character, every situation is making fun of some real thing, right? So there's this libertarian trillionaire who bankrolls the campaign, and Prezibot wins the Republican primary. Also because it's the only moderate in the field of all populists, the opposite of Trump, who was the only populist in the field of all, moderates. Now it's the other way around. And then there's like this, oh shit moment of like, wow, we are in the general election now. And there's this dozen-person startup with a crappy, buggy, hallucinating chatbot. And of course, now I up the stakes. The other candidate, the Democrat one, is a fake Lakota chief who wants to abolish the United States. So here's a bunch of bumbling fools with their delusions, but if they fail, it's the end of America, and this is where the book starts. It starts at the first debate with Ethan terrified that, Prezibot is going to hallucinate something and completely blow up the campaign. And it only gets worse from there.
Yeah, and of course the Prezi bot is almost a bit of a piss take of something like ChatGPT.
Of course, yeah.
Indeed. But I mean, your novel portrays AI and tech companies in a very negative light. Do you actually believe that AI and big tech poses real dangers to society?
I would say that I know that some people will read the book as showing them in a very negative light. I would actually contend that it actually shows them. So first of all, a satire is a form of critique, right? It's critique via caricature. And that's what I'm doing. And again, this is a long tradition in science fiction is you extrapolate. So I'm caricaturing AI and the tech world and the culture for a purpose. It is to criticize it. But at the same time, right, first of all, these guys do have invented an important new technology, which the company, this giant trying to acquire them, they do admit to that and check it. So it's not like they're complete bozos. Just like the guys at OpenAI aren't bozos. They're very good people. They're just a little deluded about how close to AI we are. And maybe the even better incarnation of this is Dave Newell, the CEO of this tech giant that, is the everything app. Right? There's a set of apps for every one of the 7 deadly sins, right? There's greed with the finance apps, there's gluttony with the, food ordering, there's lust, blah, 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 right? And he, of course, he's inspired by CEOs that you know very well, right? And he is so he believes that he's in charge of humanity's happiness. He's very modest. He has the responsibility on his shoulders because he created this thing called the neurosniffer, which again is a spoof of how ad targeting works, that sniffs your pheromones and knows what state you're in. Like this is a device that a little sniffing chip that you put on your cell phone. Yeah. It sniffs your pheromones and figures out where your emotional state and what buttons to push to, for example, make you hungry for a beer or make you want to buy whatever, right? And again, this is a caricature of the real thing. Right. Also more effective of like what companies do today. But he's a character that gets his comeuppance in the novel without giving any spoilers. Right. But I try in the book to give him his due. In many ways, what he's doing is good. And in many ways, he is well-intentioned. He does not cynically believe that he's in charge of humanity's happiness. He is less in charge of it than he thinks. That's how he's deluded. Of course, he's also trying to make money, and this also comes up as like, when push comes to shove, when the choice is between happiness and making money, he goes for making money. That part he doesn't talk about, again, like some of the CEOs that we know. But I think this is true of the tech industry at large. The thing that drives people in the tech industry, from the lowest engineer to the trillionaire CEO, is to make the world a better place. In sharp contrast with, for example, the finance industry, where I've also worked, where people are there to make money. The first rule, like Michael Lewis said, is don't talk about the money, but that's what they're there for. The reason why engineers get paid so much less, and therefore the companies are worth so much more compared to the banks, is that they're in it to change the world. So they really do believe in that. But of course, they're naive about it. That's some of what the novel makes fun of. And in some ways, they're not quite being as idealistic as they like to think they are. But the industry as a whole, the idealism is good, the other stuff isn't, and you should, and I mean, at the end of the day, 24 is also the story of the birth of a better technology, of a better way to use AI for the greater good, as we've been talking about. So in that sense, it's actually a very hopeful book, right? It's not a negative book in that regard.
Yeah, I'm a huge fan of Michael Lewis, by the way. Flash Boys, I read that a while back. Absolutely brilliant. But you do portray the tech CEOs, though, as being kind of narcissistic, power-hungry, messianic. How is that commensurate to, the Valley right now?
I mean, they are.
Okay. Well, you said it. Yeah.
One of people's favorite scenes in the book, it's funny because my son read the book early on, and when he was at one point, we were in a hotel on vacation, and he starts laughing out loud. And I'm like, oh, this is a good sign. He's laughing out loud reading 2040. And I'm like, so what part are you reading? And there's this chapter where the billionaire the trillionaire that bankrolled Prezibot. So there's a fundraiser for Prezibot being held at the mansion of Dave Newell, the head of this company that has acquired the startup. No big spoiler that you can kind of that's going to happen one or another. And he's holding a fundraiser. And then in his Versailles themed mansion, right, on the lawn, but the other guy isn't showing up. He finally shows up in his helicopter, lands on the lawn, blowing everyone's plates, and they proceed to get into this argument about who is saving the world more. In fact, the chapter is entitled "Only We Can Save the Planet," and it's like, I have a better carbon offset scheme, your scheme doesn't work, and then I'm going to get to Jupiter before you do, but I'll get to Saturn before, and my rockets take off from this island that I bought, and and finally generates into a fist fight where they throw lobster at each other, and their bodyguards have to keep them apart and whatnot. And I think people find this funny because first of all, there's an element of slapstick and like typical satire to it, but like this is very much a caricature of the narcissistic, messianic, power-hungry side of these tech moguls, which they do have. There's also one in there, just to be fair, right? It's the 3 trillionaires. One of them is this guy called Thomas Monk, who invented this thing called karma coin. And he's now a Buddhist monk, and he's given up all worldly possessions. He's very quiet and doesn't take part in that big fight. And again, he's also inspired by some real, CEOs. So there's also that element.
On Prezibot, I mean, you were kind of sketching out this approach to direct democracy, and we spoke about this earlier. But do you think that would actually be a bad thing?
So what I find fascinating about AI from the point of view of politics is that it potentially solves the oldest dilemma in all of democracy, which is the dilemma between direct and representative democracy.
Yeah.
Each of these has its challenges. The problem with direct democracy is that it doesn't scale. If we could take all decisions by going in the agora and debating it as they did in Athens, that would be a lot better than having, representatives in the House. The problem is it doesn't scale. The problem with the House, but scaling is a problem that can be solved by technology. That's the thing, right? We know how to scale now. And then and then representative democracy, like in the House, you have a representative with me and 70,000 other people. That has its own problems, one of which is the cognitive limitations of the representatives. Even if they want to know me and serve me as best as they can, like they can't know 70,000, there's only so much they can do, right? But the even bigger one is they have a conflict of interest. The big problem with representative democracy is the conflict of interest between you and your representative. What AI potentially solves in Prezibot 2.0, it's the second version of Prezibot, illustrates, and a large part of the novel is Ethan coming to this realization through a series of instances, is that like you can solve this problem with AI. You can actually have a direct democracy that has all the benefits of representative democracy by having your model do your job for you, of intervening in the political process, and you can take over from your model anytime you want, right? Prezibot is an AI, is a vast data center, right, which covers the entire underground of San Francisco, that is listening in real time to what everybody's saying and figuring out what to do and where to go. We can actually do this today technologically.
But isn't this almost ironic, though, that you're conservative, and what you're arguing for is, it sounds, correct me if I'm wrong, like a kind of AI neo-Marxism, where we've got a machine that's kind of, understands all of us?
That is a great question in multiple ways. So first of all, I do not, sorry to disappoint some people, think of myself as a conservative.
I'm sorry. Yeah.
Because don't apologize. That's first of all, on any grounds, there's nothing wrong with people being considered whatever, right? So, but here's the thing. In many ways, I am an ultra-progressive.
Yeah.
Conservatives, going back to Burke and whatnot, their whole idea is that like things don't change that much, and no, we got to preserve the good. Now, I do AI research. I'm for the fastest possible progress, and I believe progress is possible. It is true that human nature doesn't change unless we start messing with it, which we can. But leaving that aside, human nature is a constant, but we can design better mechanisms. Like democratic constitutions and justice systems and whatnot. So perfectibility is possible. Now, so by that standard, I'm a radical progressive. The problem is that the biggest reactionaries in the world today are progressives. It's this top disturbed world that we live in, that like the real conservatives are the progressives. Like there's no bigger reactionary than an environmentalist. Environmentalists are people who like every little thing that we touch in the planet is bad. We just have to go back to this mythical primeval state where the planet wasn't touched by us, right? That stuff gives me the EBGB. So I'm not a conservative in that sense, right? In the sense of like, who do I lean more towards in terms of like the parties and what they stand for? I do lean more towards conservatives. Obviously, that wasn't always the case, right? I was born in Portugal. There was a revolution there. Like being right wing was like worse than being the devil, right? And I voted for Biden, for example, right? Even that recently, right? But unfortunately, when you look at the issues these days, I went from being, I would say, center left to being center right. But now to get to the question of what I'm depicting is a kind of Marxism. That is a beautiful question because it actually gets to the heart of what I'm suggesting here. Contrast that with what you were saying earlier about Ayn Rand and the libertarian, view, right? And the thing is that looking at this through the prism of mechanism design, the mechanism that Ayn Rand is proposing is not that good at the end of the day because it has these flaws. The mechanism that Marx was proposing is even worse. Between libertarianism and communism, I will pick libertarianism any day of the week, right? He had the mechanism for organizing society, which without getting into the details of it is a massive failure. And we can get into why. There's interesting reasons. Some of it actually has to do with just a conflict of interest. A lot of it has to do with, and they're very germane to Prezibot and what we're talking about here is like, the intelligence of a communist society is dramatically lower than the intelligence of a market economy, and that is the problem. The famous question that some visiting Soviet asked, like, but who is in charge of the bread supply to London? He couldn't understand that. The bread supply to London is handled far more intelligently by the market than by central planning. So that attempt at mechanism design is a terrible failure. But again, what could Marx possibly imagine? What I'm suggesting here is nothing less than a different political system that is better than libertarianism. It's better than Marxism. It's better than anything we have today. It's something that Milton Friedman couldn't have imagined, or Keynes, or Marx, or whoever. Like, the technology for that didn't exist. But we have the technology to create a better functioning, more effective, more democratic society than we had before in the ways that we've been describing.
Now, the novel presents a very dystopian near future America with extreme polarization and violence and, societal breakdown and so on. And there are some very dark turns at the end. Do you think that this could actually realistically happen?
2040 is not about 2040 any more than Animal Farm is about animals and farming.
Yeah.
2040 is a caricature of 2024. I'm trying to talk to people about the present time by giving them an impressionistic portrait of politics, culture, tech, society as it is now. And what I've found from people reading is that they have no trouble whatsoever recognizing what I'm caricaturing and how. In fact, a typical reaction to this is like, wow, this is so far out, so over the top, and yet oddly realistic, like it could happen tomorrow. And that was indeed the purpose. Now, I think I am an optimist at heart, but I do think unfortunately that things are going to get worse before they get better. So even though 2040 is meant to be a caricature, and some aspects are like quite clearly a caricature, it's not impossible that all of that could happen. But to give a very salient example, why is there this fake Lakota chief seeking to abolish the United States, right? Some of this is a commentary on how you get, he is an influencer who, he pretended to invade the United States from this reservation, and on social media it went viral, and then Fox News pretended it was a real invasion, right? So there's that level of commentary, but why would something like that fly, right? If you think, I like to take, I did this in the master algorithm, take each school on its own merits. I wanted each chapter to be like, if you're a Bayesian, it's like, this is the best description. I don't want to sell my thing, right? This is not what a good novel does. So I take, those woke progressives, etc., at their at face value, and I ask the question: if I follow your law, 2040 in every department, from tech to AI, is, say, a very standard science fiction is like, if I take this logic that is in play today, and I follow it to its logical conclusions, where does it lead to? And if you follow the logic of wokeism, it leads to the abolition of the United States. Because this is all a bunch of colonials, it's settler colonialism. What we did was massacre the natives and blah, blah, blah. And really, what Raging Bull, the Democratic candidate, is saying is like, we need to replace the United States by a federation of indigenous nations. Each tribe has its own territory. We're not going to kill you all, right? It's like, one of the first questions in the debate, like, what do you tell people that are worried about, their home? And it's like, no, you'll still have your home. It'll just be ruled by the local tribe. But then she asks, but then what's going to happen to them? And goes like, well, the buffalo need land to graze, so, there'll be choices to make. So I don't think this is going to happen. There's not going to be a fake Native American chief trying to abolish the United States. But you can see less caricatural versions of that already at play today.
You are very, very pessimistic, though, about the trajectory of US politics and society. And you mentioned Raging Bull as well. I mean, are you concerned that the depiction might be seen as mocking or trivializing indigenous peoples?
So that's a very interesting question. I have libertarian friends and liberal friends. The libertarian friends typically say that my caricature of wokeism, by the way, it's not just Raging Bull. 2040, again, this is another one of those thought experiments. 2040 takes place in a world where the wokes won. Wokeism prevailed. Wokeism now rules society. But then, of course, part of the humor is that, like, they are now the old generation. They're the dinosaurs. The new generation is dying to get out from under their thumb. And this is illustrated in multiple ways, which, of course, again, is a commentary. When the wokes like to say, like, oh, you people criticizing us, you're a bunch of old fogies. You're the dinosaurs, right? We actually talked about this before, right? Yeah. And it's like, maybe you're the dinosaurs, you just don't realize it yet. And again, this operationalizes that. So the whole society has become ruled by wokeism. And now we get to see all of its pathologies and how it is in old age and whatnot. Mm-hmm. And in a sense, Raging Bull is the ultimate encapsulation of this. So 2040 is a dystopia, right? Yeah. A lot of dystopian things have happened. But there is a message of hope. There's a lot of disasters that happen. And I think, what Churchill said, right? America's, they always do the right thing after trying every other option.
Yeah.
And I think this is a little bit in that spirit. Are there people who say that this is offensive to Native Americans, for example?
Yes.
And so my libertarian friends, if you will, my conservative friends, they tend to say that the caricature of wokeism hasn't gone far enough. The typical reaction from my liberal friends is like, your caricature of wokeism is too exaggerated. It's so unrealistic that I don't quite buy it. Mm. And this is a perfectly reasonable spectrum of opinions. I'm glad, because I didn't know what would happen, that I wrote the novel well enough that they don't say this is offensive and beyond the pale, which is what the natural reaction of a woke person would be to the novel, is that like, oh, you're making fun of Native Americans, how dare you? And so there are several things in that novel whose purpose is to distinguish Raging Bull from Native Americans, which again is criticizing a real mistake that wokes make. Is like, Raging Bull, first of all, he's not a Native American. He has 1024th, which of course is a spoof of Elizabeth Warren. He's pretending to be because it's convenient. And again, we have examples these days of like Berkeley professors who made a career pretending to be Native American and then were exposed. I don't know if you know about this, but this is real today. So again, that is a caricature of something that really happens. And so now, he's actually a white guy, and he's an individual who's running for president. He's not there to represent the Native Americans. And in fact, some of the dialogue in the book is like, a lot of the Native Americans think you're a clown, you're an idiot, you're a fraud, right? So it's very clear that he doesn't represent them. So as much as this book has a very sarcastic portrait of wokeism, I actually think the reaction to it from left-wing people has been good, in that they recognize that this is a satire. And moreover, I think a good satire makes fun of everybody equally. Satire that just makes fun of one side is not real satire. Most of the book is making satire of the Republican side because it's the story of Kumbaya and President. But I wanted to make a satire of the other side that was just as pungent. And I think, from people's spectrum of reactions, that actually is what the book does.
And why did you choose the satire strategy?
Oh, very good question. People often ask me, this is a bit of a departure for you, right? You're a scientist, you wrote a popular science book, and now you write not only a novel, but a satire. Well, there's a couple of reasons. The most basic reason is that there's just so much to satirize in the tech world, and in particular in the current moment in AI. The current moment in AI is the most exciting moment I've been in AI for decades, right? This is the most exciting moment we've ever been in. We're making very rapid progress. People shouldn't deny that. We're having impact like never before. And the difference that good research makes has never been greater. At the same time, the current state of AI can only be described as farcical. OpenAI, with my apologies to all the good people at OpenAI, is farcical. Everything that they do winds up backfiring or working for a different reason than it was intended to. And this has been the case both in terms of the technology, going all the way back to embeddings and et cetera, right? And large language models. Like, this is a farce. Large language model is solving AI down to like, so there's a lot to satirize. Let me just put it that way. And in all of these aspects. But then also I've thought for a long time that someone should write a novel about Silicon Valley, about the tech industry. And my inspiration for this was The Bonfire of the Vanities, which is a satire. It's a satire of the finance industry back when it was the iconic industry in the 80s and is often considered the greatest novel of the 80s. So what I'm trying to do here, in a way, is write the bonfire of the vanities of the tech industry, which of course in style is very different because, we don't have the time for those long, very well done descriptions. It's a very rapid fire book that's more like, social media and what people are used to today.
But the spirit of the question is, Andrew Doyle created this satirical character, Titiana McGrath.
Yes.
And I think there was an element of he wanted to defend against criticism.
Of himself?
Yes, because if you satirize it, it's comedy and it's a great shield.
No, well, so satire can work as a shield in two ways. One is that it's like the court jester, right? The court jester is a beautiful character because he's the only one who's allowed to criticize the king. Mm-hmm. And humor actually has a very important part in human society, which is, and it's been playing that forever and it continues to do that now, which is it allows you to say out loud the things that you're not supposed to say. But actually it's important that they be said. And then you laugh at them and say like, well, I didn't take it seriously, but your brain received the message. So I'm very much playing that game here completely explicitly, right? Like completely deliberately. So in that regard, yes, satire is a good medium for that. There is another aspect to this, however, which was, of course, the part of what's funny about Titania McGrath is that it's a different character. It's a pseudonym. So it's like, Nabokov writing Lolita, right? He's like, don't pin that on me. I'm not a pervert. This is a guy writing about a manuscript that he got from another guy. And I, the author, am several steps removed from it, right? Very clever move. But like my agent, right? When he first saw this manuscript, one of his first suggestions was, maybe you should think about publishing this book under a pseudonym. Because if you don't, they'll come for you. The wokes will come for you. The publishing industry in America right now consists of the wokes and the people who are terrified of the wokes, which is a lot like the education industry. But like, this is the state of things. And I
come for you again. Come for you again.
No, but it's like, I had to laugh, and I said, I welcome their hate. Right? I didn't say this, but this was the summary. That like, first of all, I'm beyond worrying about the wokes hating me for obvious reasons, but also, and then he completely agreed with this, like, writing the book under a pseudonym would actually undermine it. Because writing this book under my name gives it the authority of someone who is an AI expert in the tech industry. I know the tech industry very well. I know a lot of these companies from top to bottom, from talking with CEOs, people alike, and you want that to give credibility to what is being described. Number one. Number two, on a very pragmatic level, one of the strands that gets people interested in 2040 is sort of like what you might call the tech gossip strand, right? There's a lot of stuff there. There's like on every page, there's an inside joke or more, right? The general public won't care. Hopefully will just laugh at things as they are. But people who are in the tech industry, they will recognize what I'm making fun of. And if the novel was under a pseudonym, people wouldn't know. Like they wouldn't, there would be one attraction of the novel that would disappear. So definitely I wouldn't want to write it under a pseudonym. Although I understand that historically many satires have been like Titania McGrath have been written as satires and they work that way.
How does living in Seattle affect, or how did it affect your book?
Well, Seattle next to Silicon Valley is the biggest center of the tech industry. So a lot of what I know is from the companies that are here. The Microsofts, the Amazons, but also all the startups of various different sizes and whatnot. At the same time, I spend a lot of my time flying to San Francisco and the Bay Area for various reasons. I spent a year there on sabbatical, Stanford and whatnot. So I think in a way this is ideal because not being in San Francisco gives me a certain ironic distance that actually it's like, famously Tocqueville writing about America, right? Like he wrote a better book for not being American. Because if you're really immersed in it, there's some of the satire and even just the insights that you don't get. So you need to, at the same time, know it very well. Otherwise, you can't write a good satire. But also have a certain ironic distance, which I can have by being in Seattle as opposed to the Bay Area.
And you do know it well. One of the articles of faith in wokeism is that people can't understand it.
Well, I'm laughing, right? Because this comes straight from postmodernism. And of course, the whole thing about postmodernism is that it's an intellectual fraud. That starts from a perfectly reasonable starting point. And again, wokeism repeats that. But the problem is that wokeism actually is not just a waste of time. It's actually noxious. I would say that I understand wokeism as well as anyone. To be fair, what I do for a living is AI. There are people who have made their full-time occupation to understand wokeism, and they understand wokeism more extensively than I do. But the key elements of how wokeism works and what it is, I think I understand them in particular way, way better than, number one, the wokes themselves, and number two, and more important, way, way better than all the useful idiots, to use Lenin's phrase. There are the people who are actually not woke, but they are the enablers of wokeism. When that 80% of the population turns around, wokeism will die. But in the meantime, it's getting its way. And again, part of the goal in this book is to make explicit how wokeism works and just point out to people how absurd it is by caricaturing it. And again, some people will not like that part of the book. It's a minor chord, if you will. And the main one is AI and tech and whatnot. But I'm doing that very deliberately. The book reflects my understanding of what wokeism is and how it works.
So let's talk about AI regulation. Now, one of the reasons I was asking about not using a pseudonym and the satirical nature of it, Gary Marcus has just written a book about very similar topics, and he gets hated on quite a lot. He really does. But he just laid it out. He didn't satirize it in any way. In his book, he was making lots of arguments about how large language models are unreliable, prone to hallucinations, yet they're being rapidly deployed. I mean, he's saying that we should more rigorously test these things and slow down. I mean, what would you say to that?
First of all, in fairness to Gary Marcus, he's had two phases in his AI critic career. I mean, he's actually a psychologist. And in the first phase of his career as an AI critic, the main thing that he was criticizing was the limitations of deep learning. He has a book called Rebooting AI, where I wrote one of the blurbs on the back saying every CEO of a tech company should read this book, and everybody else as well. Because I disagree with him on some things, agree on others. He's not as well informed as someone in the field. But by and large, and you can read that book today, even after all the progress, his criticisms of deep learning are on the mark. Sorry, I mean, that's just reality. And he got hated by a lot of people because, when you have a parade going, you don't want someone to rain on it. So, I spent a lot of time in the last decade telling my deep learning friends, Gary is annoying, but he's not wrong about everything. How do you solve this problem? And so I sympathize with that part of him, right? And I think it's very important to have informed critics. Most of the critics of AI, honestly, it's the people who don't know anything about it, and it's like ridiculous, and they're doing real damage. Gary is not one of those. He's in an AI adjacent field, cognitive psychology. He was students of Steve Pinker. People like that are worth listening to, and the bigger the hype, the more we need to listen to them. I want people criticizing my pretensions and my illusions. I'm like, please, and then I argue with them, and then we both hopefully wind up more enlightened. Now, I think at one point he very consciously made a pivot because his shtick was like, deep learning sucks, it doesn't work, but then it just went from one success to another. And I don't think he's changed his mind about those things, but he realized, and he's a pretty savvy guy in many ways, that I can't keep flying this plane. You're still saying after ChatGPT that deep learning doesn't work. So he pivoted to being an AI critic of the form, AI is too dangerous.
Yeah,
and unfortunately, I have zero sympathy for the new persona of Gary Marcus. Because, again, in contrast to his previous criticisms, the new ones, honestly, to the extent that I follow them, and I don't follow them that much anymore, sadly, he's just saying the same misguided, misleading, uninformed stuff that bazillions of other people are saying. So I actually don't you want to hear people tell you things that you don't know already, right?
Yeah.
But I don't think he's doing that. In particular, all of his calls for regulation and this is so wrong, and it's dangerous and it's bad. And I'll give you a concrete example. Europe has already passed a draconian AI regulation in the form of the AI Act, and it's a disaster for Europe. It's something that is so. when I talk to like congressional staffers and sometimes even like senators and congress people and whatnot, like I say this to them. I actually said this to Mike Johnson, the Speaker of the House, this week. I was at a dinner with him, and I said, like, whatever is in the AI Act, just do the opposite, and you're already off to a good start. This is not the main point. The main point that and in fact, this encompasses all things like, is there a need for federal AI regulation? And my answer is, the number one thing that federal AI regulation needs to do right now and urgently is preempt state-level regulation, just like they did for the internet. Congress's approach to the internet was incredibly enlightened, and they didn't come to it easily. Europe didn't do the same. Well, look at where we are now, right? Europe has 0 tech giants, and America and China have all of them. China, right? They're about to do the same thing with AI now. Look at SB 1047. This is a complete disaster. And it's all this idea that, honestly, I think it's born of intellectual arrogance. It's this notion that, like, AI is unreliable, so you should let us control it. And again, 2040 is precisely a metaphor for this. Like, the MacGuffin in 2040 is the kill switch of Prezibot. And then the problem is that Ethan loses. And it's why do we have kill switches? Because in the worst case, if AI misbehaves, is too unreliable, or becomes evil, we can switch it off or take control. So Ethan has a kill switch for Prezibot. But the problem is that he then loses it. So when you create a kill switch to control AI, you have to ask the question, whose hands is that kill switch going to be in? And of course, what happens in 24 is that, like, there's this big scramble to get hold and control the kill switch. And then what he realizes is, like, no, everybody should have a kill switch. So they turn the kill switch into Prezi app, which is an app that everybody has on their phone. So I'm very much a believer in open source AI. And again, this is a lesson that we have already learned. Closed source software sucks because there's only Microsoft employees, improving Windows, whereas Linux, it's everybody. We need to do that with AI to an even greater degree. So these things that people like Gary Marcus and Stuart Russell and others are proposing, they're not only not good, they are bad. They are the opposite, the polar opposite of what we need to do.
I think many people would agree with what you've just said. So the regulation as it is now is broken. The compute thresholds is an absolute nightmare. I had Sarah Hooker on about that, so we don't need to go there. But the audience knows it's absolutely ridiculous. There's an incentives problem, and it's a different problem in the EU and the US. But the thing is, though, when you look at some of these examples that Gary cited, and by the way, I feel sorry for Gary because I just published his keynote. 98% of the comments say, "Oh, this guy's a clown." I mean, he's got a PhD from MIT. He sold an AI company. He worked under Steven Pinker. I mean,
he's definitely not a clown.
He's not a clown, but he has pivoted to safetyism along with many other people in the AI space, like Benjo, etc. And I think a lot of people don't like that. So I agree with all of that. But just to be concrete about it, because probably we would agree that some regulation is required. It's just how it's done. So he points out hallucinations, transparency around the AI training data. He points out misinformation, manipulating public opinion, having an independent AI regulatory agency with real enforcement powers, expanding legal liability for AI literacy, education. I'm just kind of like flicking through some of my notes here, but you get the idea. He's saying it's going to exacerbate inequality. He calls for universal basic income. It's going to be driven too much by commercial interest rather than public benefit. You see where I'm going with this. I mean, the thing is, this is legitimate, right? Sure.
No, I mean, honestly, we can go through each one of those as much as you want. Some of these things are just ridiculous. Okay. Others are valid concerns, but regulation is not the solution. And again, the intellectual arrogance is on full display there. Really, AI is going to be driven by commercial interests, so what we need is government regulation to tamp down on it. How well has that worked out in the past? Right? There I sympathize with the libertarians, right? Milton Friedman had a great line on this, right? It's like, what society is not driven by greed? And what happens when you try to tamp down on the greed? Like, would you have Google? It's like, all of that is just like, professors who don't know how the real world works. Honestly, I'm a professor, but come on, get a life and see how the world really works. And it's like, I mean, it's useful maybe to go through a couple of these concrete examples. Like, let's just take, for example, transparency, right? Or hallucinations, like take your name, or
copyright.
copyright is an interesting case, but not as important. So let's look at it. I think the most important problem that these models have today is reliability.
Yeah.
Okay. So really, the solution to that is regulation that mandates the AI to be reliable. You gotta be kidding. That regulation is gonna do nothing of the kind. It's just gonna slow down AI. It's gonna create a huge, like for example, the AI Act and the SB 1047, they have these mandates for companies to do all of this testing and blah, 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 that nobody knows how to do today. You are putting into law something that people don't even know how to do. Are you serious? Is this a joke? The AI Act, actually, the best part of the AI Act is that it outright outlaws a whole series of important applications of AI in the name of that they're too high risk. Like, for example, it outlaws emotion recognition because it's too invasive. I mean, like, you and I can talk to each other productively without emotion recognition. Why would an AI be able to, if you want better, more reliable chatbots, they need to have emotion recognition. And the European Union just outlawed it. This is absurd.
But I agree. It's being done wrong. But would you accept that there are, if we don't regulate, there will be problems?
No, very good. So now let's get to the general point, which in some ways is the most important one. Does AI need regulated, and how should it be regulated? And what I believe very strongly, and I'm definitely not alone in believing that, is that AI qua AI should not be regulated at all. Trying to regulate AI is like trying to regulate mathematics. We should regulate calculus because bad guys will use calculus to make rockets and attack us. Or we should regulate quantum mechanics because nuclear bombs will be made using quantum mechanics. This is ridiculous. We should regulate Python because the bad guys will write Python scripts to steal our credit card information. No. What needs to be regulated is not AI, quantum mechanics, or Python. It's the specific applications.
Yeah.
Self-driving cars should be regulated as cars. And there, indeed, the regulatory regime needs to change. And again, across the board, what happens is the laws are made with the assumption that decisions are made by people. When the decisions are made by machines, the dangers are different. And in fact, in many ways, and I can give concrete examples, you can relax or throw out regulations that are a problem when people do things, but aren't when AI does. No one is talking about that part. It's all more regulation, as if regulation is a free lunch. Now, certain things about medical applications, etc. So individual applications should be regulated within the existing regime. Creating an AI regulatory, AI is everything. Another problem with the AI Act is that if you look at the definition of AI, it's everything. Your laptop is AI. And then you know how the bureaucratic state works. Before you know it, they're going to be regulating your laptop as AI. This is just completely misguided. So you need to regulate applications one at a time within the existing framework. Like, how does AI change regulation of cars, of planes, of drug discovery, et cetera, et cetera? That is the appropriate framework, not let's go regulate AI. Unfortunately, what you have right now is a scramble among lawmakers in various countries to be the one that wrote the AI bill. There's 1,000 AI bills have been introduced in the United States since ChatGPT came out. Each one of them worse than the next.
But in a way, Gary spoke about this. He said there's an imbalance between the pace of innovation and the speed that we can regulate and our ability to understand it. Election interference is a good one. So we've got an election coming up. This stuff is actually happening now. Like, what are we supposed to do?
AI innovates faster than you can regulate it.
Yeah.
The answer to that question is not try to regulate it, because that is guaranteed to not work. We told the people in Europe that by the time they passed the AI Act, their definition of AI would be outdated, and a lot of the regulations ensuing. They ignored it. As the act was about to come out, ChatGPT came out, and they had to scramble to revise the definition to now apply. And in 2 years, it'll be outdated again. And of course, the biggest joke is the model count, the parameter count of the models. Like, we needn't go into that, but. Yeah. Here's the interesting and important question that I try to talk to lawmakers about. And unfortunately for them, I think at this point, it's still a big leap. Is like, you can't regulate a fast evolving technology, in particular machine learning, with a fixed set of rules, which is what lawyers know. You can regulate cars, planes, maybe drugs with a fixed set of rules. The only way you can regulate AI is by having your own AI that is guided by your value function. What the government needs to have is AI in every one of its departments talking with the AIs of the Googles and everybody. And this already happens, for example, in the stock market. Like, the AI is checking whether the trades are legitimate. And then what the lawmakers do as our representatives is they write the value function for the AI. This is what works.
That sounds almost dystopian, though, because what you're describing is Pressibot. And it's now something that is becoming a black box that we can describe something about it. There's a parameter, there's a value function, but the behavior is inscrutable.
This is a different but also a great point, right? Which gets back to another things that you mentioned, Gary talked about, which is transparency.
Yeah.
Right? There's another big obsessions that people have. And there's several things to be said here. One is that transparency is good. It's like motherhood and apple pie. Who doesn't want transparency? But there is a trade-off between transparency and accuracy, which again, the European legislature just don't understand. If I have the choice between being diagnosed by a system that is 99% accurate and completely opaque, and one that is very transparent but is 80% accurate, I want the 99% one. You may make a different choice, but the point is you should not have legislation imposing the latter one on you. So transparency is good, but there's a trade-off. The problem with a lot of these, AI ethics people and the legislators, they're not thinking about the trade-offs and the unintended consequences and whatnot. Now, part one. Part two, the way you improve transparency is not by having a regulatory commission that mandates that your models be transparent. Are you kidding? That's where the research comes in. The other AI paradigms are not as opaque as neural networks. It's like a lot of people today treat opacity as if it's axiomatic. It's an unavoidable property of AI. False. Bayesian networks, symbolic knowledge bases, even some types of neural networks are not opaque. They don't have to be. So we need to work on that. What we need is incentives to make that better. But now there's two more points, right? Very important ones. One is the whole point of AI is, like, for example, Pressibot, is that they can be more intelligent than us. That's why I'm in this field for. I'm in here for the superintelligence at our service. And so if you take that seriously, for example, we create an AI to cure cancer. It understands cell metabolism better than any human can. And that's what's good about it. 1,000 different humans can talk to you about it at different aspects and certify themselves that it worked, blah, blah, blah. You can have all of that. But at the end of the day, if it really is more intelligent than us and has more knowledge, some opacity is unavoidable. But now you need to distinguish the good opacity from the bad avoidable opacity. And I'll give you one more thought, which I thought was really good. I saw this interview recently with the AI chief of Kaiser, the biggest health insurance in the US. And of course, this whole thing came up like, this medical AI is so, opaque. And he said, Tylenol is opaque. We don't know how Tylenol works, but we all use it every day. He said, and I think everybody should remember this, transparent, I forget his exact words, but transparency is just a proxy for trust. What is really important is that I trust the AI, I trust Tylenol, I trust Pressibot. Some of that comes from being able to inspect the system. Some of that comes from knowing what the mechanism is and being able to verify that the mechanism is, that it is operating according to that mechanism. Some of it often, and this is actually the most common one, is I trust Tylenol because over and over it works. We trust each other because over and over, I know that this employee will more or less do certain things that they're supposed to do. And we're already developing that kind of relationship with ChatGPT. It's I know that these things it can do reliably, the others not, so I'll do the reliable ones, which often are very few in the end, but not the others.
I agree it's not transparency, it's trust. And to me, trust is predictability. But if Gary was here now, he would say, Pedro, the whole thing I'm arguing is that we're moving too fast. This is not reliable. It's brittle. Could you imagine what would happen if we took current AI and we...
And that to me is the most important point of all. We are not moving too fast. We're moving too slowly. You know why we're moving too slowly? Because the big danger from AI is not the AI being too intelligent, is that it's being too stupid. People have this fear that computers will get too smart and take over the world. But the real problem is that they're too stupid and they've already taken over the world. This is not a hypothetical danger. Computers are making bad decisions every day because they have no common sense. It's a model, for crying out loud. It learned from that data. It doesn't know anything, right? The model is amazing. It's learned from 1 trillion words or whatever. But at some level, the computer is very stupid. The way you make the computer safe, transparent, explainable, reliable, all of these things is by speeding up the progress of AI, not slowing it down. All of these, it's funny because there are the long-term AI doomers about Terminator and the short-term ones about bias and disinformation, blah, blah, blah. And they actually hate each other because they actually think that, the other one is distracting from the real problem, right? And to me, bring the popcorn, right? But here's the thing. They all agree on something, which is we got to tamp down on AI, we got to slow it down, we need a moratorium or not. They are 180 degrees wrong. What we need is faster development of AI. That's what will make it smarter, safer, all of those things.
The incentives are completely broken in how regulation is enacted. Loads of the tech industry spend millions and millions of pounds or dollars here lobbying to influence regulation. What's the impact of that?
Well, so first of all, part of my beef with the AI regulation mavens is that they have this very naive, very left-wing view of regulation. There's a problem, regulation will solve it. They don't realize that government, and I mean, honestly, it took me a while to realize this. I remember when I first came to America, and I didn't even know, for example, libertarianism, and hearing things like, I think it was Ronald Reagan that says, government is the problem, it's not the solution. I'm what can he be talking about, literally? And the truth is, government is both part of the solution and part of the problem. But you have to recognize the part of the problem part, and they don't. So one of the problems, of course, is regulatory capture. Hello, people, have you heard of regulatory capture? Have you actually played out in your head the thought experiment of what will happen when you pass these laws? What the regulatory capture is going to look like? What the bureaucratic state that is going to grow like a cancer? And like you said, I've had this conversation with some people oh, but this is just reporting the characteristics of the model. It's very harmless. And I'm like, but what does the reporting it accomplish? Number one, on a large company, it's not a burden. On a startup, it is. But then this is going to metastasize into 10 years from now, you have to write 1,000 pages every 3 months about what your and none of it is doing anything useful. Number one, right? And then there's the whole lobbying part, which of course, let me say this. Lobbying is actually an important part of the democratic process. I'm not against lobbyism per se. Again, we're very good at externalizing our evils, right? Wall Street is greedy on our behalf, politicians lie on our behalf, etc. So if I'm a company and I have something important at stake in some pending legislation, it behooves me. It is my fiduciary duty to go lobby Congress about the legislation. It is what I am supposed to do. I shouldn't lie, I should stay within the law, all of that. I should lobby. There's a couple of problems with this, obviously, or provisos. The lobbying must be in the open. Again, what we want is a president-like system where you can see what everybody's saying. No, behind the doors, none of that, right? So the lobbying I must know that you're lobbying and what the content of your lobbying is, number one. Number two, there's a problem of resources, right? If you're Google, you have a lot of resources to bring to bear on lobbying on your behalf, right? And you want what you want to make good decisions is a balance, right, of the evidence that is not skewed overly by the resources of some party, but that in democracy just happens left and right. By the way, one of the most important things that something like President 2.0 can solve is the collective action problem. Is the tyranny of the minorities that are well organized, and for them, the benefit of acting is higher than the threshold as opposed to the diffuse interest, which is of all of us. And so we have agricultural subsidies, we have all of these things. If technology lowers the cost of coordination, AI, the internet, right, crowdsourcing. So we, the diffuse interest, can now actually go and combat the concentrated interest. So we need that part to happen, right? We, however, also need, and again, my more left-wing friends have a tendency to not appreciate this. I'll give you a grand example of this. Climate change, right? You're always hearing this thing about the oil companies, they're so powerful and they spend billions of dollars combating, spreading. There's books written by fellow, professors of mine about this. Here's the thing. First of all, the money that they've spent is insignificant compared to the money that is spent in the educational system every day, telling children from cradle to grave the other side of the story. I'm not saying which side is right or not. I'm just pointing out that the resource imbalance is on the other side. And by the way, the philosophy comes, they're not even trying to do it anymore. They gave up. So when you think about the resource imbalance, you have to think about, for example, the groups that are organized and have a large influence in the political parties, like, for example, unions famously, right? Like they created the Labor Party to serve their interests, right? So you got to think about all of those sources of power, not just the money of the tech companies.
Yeah, I mean, I understand what you're saying. It's a free market, and as long as all of the interest groups are well capitalized, then everyone is represented. But just to bring a couple of specific examples, I mean, copyright infringement, privacy violations. These AI systems, they're hoovering up vast amounts of data. And what the tech companies do is there's so little friction between their actions and the legal framework because they operate in the virtual world. And it allows them to basically do what they want and get away with it for a very long time. I mean, surely you think we should do something.
So let's do this one at a time. Copyright is in some ways the simpler one. Copyright is actually a very interesting case because, for example, the New York Times has sued OpenAI, right? In a very Machiavellianly contrived way, but let's, look at the core of the issue. I believe, but this is only part one, that copyright law as it stands today absolutely protects things like LLMs. Because if I'm a painter and I'm influenced by Van Gogh and Picasso, I don't owe them royalties when I make a painting inspired by them. And this is what these models do. Right? They're completely protected by current copyright law. If the model regurgitates a copy of your painting, then it's violating that, but that can be avoided. Part of the contrivancy the New York Times was to pretend that this happens a lot more than it does. That I think can be solved. But part one is AIs are protected by current copyright law, in particular machine learning. Machine learning is about generalizing and creating new things. That is it's not just fair use. It's like, you got to recognize the AI as the creator of a new book or painting or video or whatever, right? There's the question of who gets the money and the liability, but that's a different question. But now here's the thing, and this actually is the more important point. This is precisely one of those areas, great example, where we do need new legislation. Because the copyright law was not created with AI in mind. The question that we and our representatives need to ask themselves is like, what is the copyright regime that we can design that will be best for society, the same way that the original one was introduced? And here's the thing. And here, actually, I violently sympathize with the content creators, the newspapers, etc. They must be rewarded for what they produce, or in the long term, they will not produce it. Yeah. Right? They must be. So what we need, and again, there are some startups that are experimenting with this, and I think we should see more of that, is we need a mechanism by which when I get, for example, a text written by ChatGPT, right? OpenAI keeps some of the money, they're entitled to it, but some of that money flows to all the source. It's back propagated. We need back propagation of the reward money to every single person, institution, newspaper, journalist, reporter that contributed, and the ones that contributed more should get more money. If you are the journalist that actually provided the real facts as opposed to the tons of opinion, you deserve a lot of that money.
I know, but look at Napster. So you could get it for free, and then Spotify came along, and it just, crumbs from the table. You can have artists aren't really getting compensated very much. So it's a bit of a problem.
No, but that's so great example. So two things there, right? How the allocation happens, who gets how much, is an economic problem. And what has happened, and I agree, the artists don't make enough money, is that unfortunately, largely because of networks and the effect and whatnot, whoever has the bottleneck winds up having a disproportionate reward, right? And that is potentially a problem. But you do not combat that problem by combating the network effects. The network effects are good. Again, the regulators keep getting this wrong, right? But the other aspect of this is that it's funny because actually musicians are doing fine today because what they do, and I was a musician once, the recorded music is a loss leader. It's an advertisement for their concerts. So it's okay if YouTube gives me pennies on the dollar for showing my stuff. It's free advertising. And then you come to my concert, then I made a ton of money. So in a way, not by design, this is actually not working that badly with Spotify and YouTube and all of that.
To be fair, that's true. I mean, I run a YouTube channel and get pennies on the dollar. But I do it because I can, sponsors come and I can go to events and so on. But anyway, one other thing though, I think part of the reason why we have this compute threshold and we have this copyright argument from OpenAI is because they are leading people to believe that these algorithms are learning abstractions. They're not just approximate retrieval systems that are memorizing the long tail. That to me feels like a difference in kind. Do you think that if people thought of them as databases, they would think differently?
No, but like again, they exaggerate this as they exaggerate a lot of things, but they're right. This is machine learning 101, is that LLMs are not stochastic parrots. Anybody who calls an LLM a stochastic parrot is just revealing their ignorance of machine learning 101. The whole point of machine learning is to generalize. I mean, like, and you can test this. And in fact, good experiments with LLMs test this. The text that you just gave me, was it regurgitated or is it different from anything in your training corpus?
Yeah, but earlier in this conversation, you did say that they were n-gram models on steroids or something.
No, well, but the steroids is a very important part.
Okay.
Right? So, I mean, maybe this is a little too in the weeds, but what happens with n-gram models is that as you grow the n, the cost of doing it becomes exponentially large, which is when you start to need intelligence. You could say that your brain is an n-gram model. It's a finite state machine. But that's kind of underselling it because the whole, and again, this is why scaling is not an afterthought, right? Being able to have effectively an n-gram model with length, blah, 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 is very important. What actually happens in practice that even if you just think about an n-gram model, which is a very kind, transformers do more than that. So let's think about even an n-gram model, when it starts to stitch together pieces, which is what it does, right? One at a time, and creates a text, as I have seen n-gram models generate, that is different from any text that was there before. It has generalized.
Yeah, I think that's still a stochastic parrot. I mean, let's agree, though, that they do learn abstractions, but they learn surface abstractions.
They learn abstractions that the folks set up. Let me give you a good straw man. Ilya Sutskever, right?
Yep.
Back when he made this argument very strongly. He said, large language models, people say that large language models are stochastic parrots because, these are not his exact words, but this is the content in our terms, because they just predict the next word. What they don't realize is that to predict the next word well over the full variety of text, you have no choice but to have a model of the world. Therefore, LLMs have a model of the world. Another problem is that he is right that, and this is important for the current state of technology, that just predicting the next word is actually an incredibly powerful thing, much more powerful than just modeling language. Having said that, he is really, and OpenAI and a lot of this crowd, they are really missing something important, which is, okay, but then by that standard, n-gram models have a model of the world. They predict the next word.
Exactly.
It's just that their model of the world is very limited.
Yeah,
and the LLM is a less limited model of the world, but compared to the one that you have in your brain, it's just a different kind of model. It has other strengths, but the stuff that you understand, it doesn't.
That's true, but it's a model of the world, but it's not a robust model of the world.
No.
If you tweak a couple of words, the whole thing's broken.
Absolutely. This is the biggest problem. In fact, Ilya himself, back in the day before the present brouhaha, he admitted, like, this is the biggest problem is the reliability. And again, it's because those were just learned from text. They have no knowledge. They don't have the knowledge of the world that a 2-year-old does. That's what's missing. Like all of these others, or most of these others, privacy is an overblown concern. When the companies mine their data, they're serving me. The biggest beneficiary of the mining of my data by these companies is me. Eric Brynjolfsson's group did a great experiment where they asked people, how much would you have to get paid to not use a search engine for a year? And it was $17,000. What is the value to Google of a single user? You divide their market cap or their yearly income by their number of users, and it's like in the hundreds of dollars, I think, right? So Google with all their mining of your data is worth orders of magnitude more to you than you are to them. So I want targeted ads, please. Like, I'm not trying to cling to my privacy. We shouldn't think in terms of privacy. We shouldn't think in terms of data sharing. What data do I want? Like, I think of data as an asset that you want to invest. You don't put your money under the mattress, right? Like, people's privacy fears are like putting your money in the mattress. It's like, oh, what if they run away with our money? The bank's incentive system ensures that they don't run with their money. I want companies that will invest my data on my behalf to bring me benefits. I don't want to keep my data under my mattress.
But with a bank, you control your money, but with your data, you don't.
No, so there's certainly a lot of ways in which the regime can be improved, right? And who knows what scuzzy outfit is going to get a hold of my data and whatnot. I agree. There are things to be done there, but let us just stay in the rule for a second. These companies that collect all your data and sell it, they sell it for like pennies. All of that, and I one of these at one point let you examine the data that they had about you, and I looked at mine and it was like almost nothing, and half of it was wrong. The bigger problem was what it didn't know and what it thought it knew that it didn't. So if all that data about you is worth 50 cents, maybe you shouldn't stay up at night about it.
Let's talk about the LLM ecosystem. Do you think it's a bubble? What's happening?
I think, unfortunately, there is a bubble growing.
Okay.
I say sadly because I don't want to be another AI winter. I think the hype has gotten far. Technology moves faster than regulation, but the hype moves even faster than the technology. So I think the technology that we have right now is major progress over what we had before. It will not get us to human level AI, unlike some folks at OpenAI others think. We need other things. Now, the worst case scenario is that the bubble crashes, the stock market crashes because of it. At this point, we're at that level, and some trillions of dollars will be lost. That could very well happen. It's completely, within the range of the possible. The better scenario, which I will try to contribute to in my own small way, is that the best case scenario is that we come up within the next year or two with the innovations they'll actually fulfill the promise that the current techniques don't have that people think they do. And so this exponential, which is really just the first part of an S-curve, will actually keep going, right? It is a little bit like the soft landing problem that the Fed has, and not entirely related. We should try to engineer a soft landing for AI, but we really are going to need new ideas, which unfortunately is part of the whole bubble. People are converging to too much of, it's a paradox, right? There's more research, AI research than ever before on fewer things than ever, and we need to diversify.
But it's only a bubble in the, there's what the public think, and then there's what people actually think. There are loads of interesting startups doing, neurosymbolic. Presumably, we just need an idea to get escape velocity, and then it would be acquired and it would just become the norm.
I agree with you. There's like tons of startups, tons of people. Like most AI research comes from universities. But to take neurosymbolic AI for just a second, something that I'm very interested in, I'm working in what you might call neurosymbolic AI. It goes back to the 80s and connection to symbol processing again. It's not a new idea. I think neurosymbolic AI is the way to go to make these things reliable and be able to reason and plan and whatnot. So I'm all on board with that. The disappointing thing about neurosymbolic AI is that this is a very old field, but it hasn't made much progress. I think so. It's not, neurosymbolic is not there to save the day and keep the stock market from crashing at this point, right? I don't think anybody would pretend that. And I think the problem, and again, I've talked a lot with the people who do this, and and I'm one of them, is that like they are trying to combine neural and symbolic AI at a very shallow level. There's a logic programming system that calls some predicates that are actual neural networks. This ain't gonna solve the problem. RAG ain't gonna solve the problem. You could think of RAG as being a very impoverished form of neurosymbolic AI. It has a database, right, which is a symbolic thing, represented in a way, blah, 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 right? It is the first thing that occurs to you when you think, like, how do I fix these problems? But RAG, at the end of the day, the symbolic part, if you will, is still only symbolic, and the neural part still hallucinates and does its whole crazy thing afterwards. So, like, there's clearly not a solution here, but I do think I have a solution.
You've been working on Tensor logic for many years now. Even when we last spoke at Europe, you were working on it then. Bring in your work on Tensor logic.
So I have been working on Tensor logic. That has been my main direction of research since going emeritus, which is 4 and something years ago. So I have put a lot of work into this now. And what I have done is very deliberately, I keep saying this to people, AI is not a sprint, it's a marathon. All these companies are trying to run AI like it's a sprint, and it's not. They're going to run 100 meters, and then they're going to be tired and stop, right? I'm trying to run the marathon. Like Einstein took 10 years to come up with general relativity. He was a genius. We're not. But if it took him 10 years, and it was just one equation at the end of the day, right? You really think AI is going to be solved with the next tweak on LLM? So because I'm now outside the system of grants and blah, 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 I can actually afford to just spend my time going for the global optimum or the deepest minimum that I can see, not falling into a local optimum with every next paper that I write. Now, it is very important to get feedback from the community. I don't believe in, scientific heroes that did all by themselves. That ain't how it works. It's always a community, even things like relativity and, of course, quantum mechanics and whatnot. So I very much, unlike, say, Steve Wolfram, I believe in being part of a community and trying to influence them and being influenced by them. What I have done in the last year or so is that, like, you can only do so much, right, with your time. And I think you really need to go very deep. And this is what I have done. And I've made a lot of progress year after year. I also still go to conferences and whatnot, like, we last met at NeurIPS. But honestly, what I feel, maybe wrongly, is that the things I see there tend to either not be relevant to what I'm trying to do or not be new to me. I mean, I've been doing AI for 40 years now. And honestly, 99% of what I see today is like, I already know what this is and why it's not going to work, why it might work and what they could do, good for them. But I have a path that I think is shorter, so it's what I've been following.
Give us an intro. What is tensor logic?
So tensor logic is a unification, and I underline unification, not just a combination, of tensor algebra and logic. And tensor algebra is what neural networks are made of. Mm-hmm. It's tensor algebra plus univariate nonlinearities is by Kolmogor's theme, the only thing you need to add. So tensor logic is tensor algebra at one level, plus these univariate nonlinearities, which lets you do all of deep learning much more easily than PyTorch or Keras or any of those things. It's a little bit like Markov logic, my previous work. A few lines will define a very powerful model for you, transformers, attention, etc. On the other hand, it's a generalization of logic programming. So you can do all of symbolic AI and logic programming in Prolog. In particular, there's Datalog, which is Prolog without the functions. Turns out that once you bring in these functions, you don't need the ones in Prolog anymore. So if you combine Datalog with tensor algebra, you can now do very elegantly all of neural networks and very elegantly all of symbolic AI. But more important, you can now do things that are very, very deep and tight combination of the two. And I'll give you, one of the key concepts, which is this. This is really just the beginning, but it's, I think, already a significant step, which to some people will be completely trivial, but to others actually news. Symbolic AI and databases are based on relations. It's all manipulating relations. A Prolog rule is combining relations into another relation. So relations are the fundamental representation of symbolic AI. The fundamental representation of neural networks is tensors. Mm-hmm. So what is the relationship between relations and tensors? Until you've answered that question, you're not getting anywhere. It turns out that the relation is incredibly simple and almost blindingly obvious, is that a relation is just a very efficient way to represent a very sparse Boolean tensor. You think of the friends relation, right? I can have a friends relation that is a matrix of 9 billion by 9 billion people, mm-hmm. but it's going to be almost all zeros, right? Not a good idea, right? But it's a matrix. And now you can have tensor, like you can take any relation and represent it very inefficiently as a Boolean tensor. And now, if you generalize those zeros and ones to be real numbers, now you have all of neural networks and tensor algebra and whatnot, right? And this is precisely what I'm doing. But now I can do that to all of the symbolic things that people know how to do with relations, because I know how the same. So the fundamental construct in tensor logic is the tensor equation, mm-hmm. which is both an equation in tensor algebra, in particular using Einstein sums, right? If people who know what they are, I think, will immediately recognize why this shows up here. It's a very elegant way to do Einstein sums on the one hand. On the other hand, a tensor equation, if you reduce the tensors to being Boolean, and your threshold function, your nonlinearity is just the threshold function, 0, 1, it's exactly a data log rule. So a data log rule and the 9 sum are the same thing. They look different, but they're the same thing.
Well, talking of Einstein, didn't he use tensors to represent gravity in his description of relativity?
No, of course. So Ein sum is Einstein sum. Yeah. It is a notation that was invented by Einstein, and he jokingly called it his great contribution to mathematics. And he developed because he was tired of writing summation signs. And it's like, why do I even need the summation signs? It's really that simple. Let me just leave them out. And what I'm going to do is say, like, any index that appears repeated implicitly summed over. And physicists use this all over the place today in quantum field theory and like everything, right? It's just a standard thing. And we have actually a generalized version of the Einstein sum in things like, NumPy and PyTorch. Mm. And the generalization is important because we do need that more generalized version. So, ironically or not, what Einstein came up with for physics is actually very useful for us here. This actually happens over and over again. Like, I forget the number of things that I have, gotten from physics and others to use in AI. But the other thing is that I think at the end of the day, this gets back to the Mandelbrot set. I really do think that at the end of the day, tensor logic is not just the language of AI. It's the best language that we're going to have to do almost everything in science to discover the real laws of physics, combining quantum mechanics and relativity. And again, look at what people do today. It's a bunch of tensor manipulations with some logic on top of it. The logic is not learnable. We can make it learnable by using tensor logic and using backprop. The prize is there to be seized.
Professor Pedro Domingos, it's been an honor.
Thanks
Thank
for
you
having
so
me.
much.
Yeah, this was great.